Morning, everyone. Good morning, good morning, good morning, good morning. Yes. So in yesterday's class, we have completed the consolidation chapter, and one problem is remaining. Give me a minute. You're fine. Yes. So good morning, everyone. Yes, 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 yes. I have finished my breakfast. Yes, yes, yes. Okay. So now we'll see one question of the previous means. Is that- yeah. Yes, yesterday we have been discussed about a lot of things, and we completed the chapter. So in the last topic, I have discussed about the consolidation test, and then I discussed how to determine the void ratio by height of solids method and void ratio method. And then I discussed about the immediate settlement, which is nothing but elastic settlement, which is going to be SI is equals to Q by E into P into 1 minus mu square into I. And finally, I have given you the contact pressure distribution. So where the contact pressure is going to be uniform, where it is going to be non-uniform, means what type of footing. Once you know whether it is uniform or non-uniform, then we can decide easily. So how to determine this pressure distribution, and I have given you all these values in yesterday's class. So now the only one question left over in this chapter, one question is left over in this chapter, the last question. So let's solve that question also. With that we can complete this chapter completely. Yes. Yeah, I hope you people are able to see this one. Yes. So now, yes. Yeah, if you please look over this question number 14. Now, everybody, have a look. Question number 14. The plan of a proposed soil heap is shown in the figure below. See, this is a plan view of a proposed soil heap. In the plan view, see the plan view, there is an irregular loaded area which is in a L shape. So now the heap will stand on the plan of a proposed soil heap is shown in the figure below. The heap will stand on a thick deposit of a soft clay with E value. What is the meaning of E value? E is equals to 15 million Newton per meter square, which means 15 into 10 to the power of 3 kilo Newton per meter square. So Young's modulus of the soil mass is 15 into 10 to the power of 3 kilonewton per meter square. The uniform pressure on the soil is assumed as whatever the pressure on the soil is assumed as, which means the pressure due to the structure is assumed as 150 kilonewton per meter square. Estimate the immediate settlement under the point marked as X. Estimate the immediate settlement under the point marked as X. Now you see, use the following data for the influence factor. So for elastic settlement, yes, you see, you observe over here, this is the L by B ratio, and now yeah, if you see the L by B ratio, now this L by B ratio, I told you I at corner. See, they are giving you the point as a corner point. I at corner, and yesterday I said you that I value depends upon L by B ratio. Now, this is the point where I want to find out. This is the point I want to find out, and I have given you the details of the soil mass, whose Young's modulus is there, and whose Q value is also going to be there. And now, for this plan, how to determine the immediate settlement? Let's see. CR, PQ, question. Last question over here. Now, this is the load area whose dimensions are this total is 120 meters, and this is 40 meters, here 20 meters, and here again it is going to be 40 meters. So now this is the corner point where I am mentioning you. This is the corner point. I need to find out the immediate settlement. Yes or no? As you know, the immediate settlement SI is nothing but Q by E into B into 1 minus mu square into I. Did they mention any footing as rigid footing over here? No, which means it is going to be a flexible. So now let's see at this point how to find out the values. See, given L by B ratio and I at corner. So which means this point should be considered as a corner point. So X should consider as corner of a rectangle because given L by B ratio and I at a corner. So X point should consider as corner of the rectangle. Now, how come I make sure this is a corner of rectangle? If I can divide into these values, means these three rectangles, number 1, number 2, number 3, then only the point will be acts like a corner of rectangle. Yes. So this point is going to be act like a corner of rectangle. Now, what are the dimensions of this one? Now, this rectangle is 40 meters by 40 meters. Okay. And what about this rectangle? 20 meters by 40 meters. And what about this one? See, this is 120. Then what about this value? This value is going to be 80 meters. So now you have to consider this point as corner of rectangle. Sir, why you are taking this point as corner of rectangle, sir? Sir, given I value is depends upon L by B ratio, sir, and that I value is at corner. So now what happened? Okay. Still, is it a problem? Okay, fine. I have observed. What about now? Is it visible now? I hope it is visible now. Every day we are facing some problem. Yeah. Okay, fine. So now you see this point X should be act like a corner of the rectangle because as they're asking I value at the corner. Okay. So now how many rectangles are there? 1, due to 1 some settlement, due to 2 some settlement, due to 3 some settlement. So yet point X, the immediate settlement is going to be S1 plus S2 plus S3. See, they did not give the Poisson's ratio. Now let's go back. You see this question. See, now this is a soft clay, right? For a soft clay, the Poisson's ratio is going to be 0.5. For a soft clay, the Poisson's ratio is going to be 0.5. And more than that, they have given these values. You see, L by B ratio. If L by B ratio is going to be 1, the I value at the corner is this value. So now let's see how to find out the I values. And now if you observe, for soft clay, Poisson's ratio is going to be 0.5. Soft clay or saturated clay, Poisson's ratio is going to be 0.5. And you see Q is going to be same and E is going to be same. E is nothing but soil. And now these values are going to be same. SI is equals to Q by E into 1 minus mu square. These are going to be same. And remaining are, you see, B into I. As a rectangle changes, width changes. B1 I1 plus B2 I2 plus B3 I3. Now, whatever the values are there, we have got these values. Now, you observe, I have Q with me given. What is the Q value given? 150 kilonewton per meter square. E value as 15 into 10 to the power of 3 kilonewton per meter square. So these are the Q value, E value and mu value. Now we need to find out the B1, I1, B2, I2 and B3, I3. Let's see for every rectangle. For 1, in the case of the 1, what is the width? Width is going to be smaller dimension and length is going to be larger dimension. Then what is L1 by B1? 80 by 40, which is going to be 2. So now for this, what is I1? You see, as I value depends upon the L by B ratio. Now let's go back to the values. You see, when the L by B value is going to be, when the L by B ratio is going to be 2, then what is the I value at corner? 0.77. So now I am finding L by B ratio for all the 3 rectangles I have made. So with that, I can find out the means I value for 2 is going to be 0.77. And if L by B ratio is going to be 1, the value is going to be 0.56. Now this value is going to be 0.77. So we got B1 and we got I1. Now for 2, you see, for the second rectangle, what is width? 40 meters. And what is length? This is also going to be 40 meters. And what is L2 by B2? 40 by 40, which is equals to 1. Then what is the I2 value? Just now I told you, if you observe, for I, L by B ratio 1, what is I value? 0.56. 0.56 from given. This we got from the given these values. Similarly, for 3, B3 is 20 meters, L3 is 40 meters. So L3 by B3, 40 by 20, which is equals to 2. Again, the I3 value is going to be same as I1, which is going to be 0.77. It's simple now. See, they have given a soil heap. Now I am finding the entire values. So now I have every value. Now you can substitute over here. Please substitute. SI is equals to Q value 150 kilonewton per meter square by 15 into 10 to the power of 3 into 1 minus 0.5 square into B1 40 into I1 0.77 plus B2 40 into 0.56 plus 20 into 0.77. So now can you please tell me what is the immediate settlement over here? Find out. So answer is going to be 0.51 5 meters. In terms of meters, mm, 514.5 mm. That's the answer. Yes, the answer is going to be 514.5 mm. Sir, is I always taken at corner? No. They mentioned the I value at corner. They mentioned the I value at corner. So that's the reason why you have to take it as corner. In the given question, they mentioned as I as corner, right? That's why. Now, please have a look over this question. They did not give Poisson's ratio for soft clay. The Poisson's ratio is going to be taken as 0.5. Sir, please explain CRPQ fifth question. Are Baba anonymous attendee. That's very easy question. You please solve it. What's the problem? You have answer over there. Apply your logic. There is no logic at all over there. Just one equation. CV equals to K by MV into gamma W. Sir, can CC value be negative, sir? Sir, the value of the CC is actually negative. Means falling slope, right? But we need to look over the magnitude only. We have to look over the magnitude. And if you are going to look over the magnitude, change in Y by change in X, you have to take. Can't we divide this into two rectangles? No, we cannot divide because this point should act as a corner of the rectangle. See, if this point is going to be center, then you have to modify everything. You remember the Newmark's method? I hope you remember the Newmark's method, right? Yes or no? Yes. So based upon the Newmark's method, you have to go to that. Whatever the previous chapters questions you want, I am going to give you today doubt clearing session would be there from 1 to 45 minutes because after 2 o'clock one more session is there. Not mine, some other class are there, so I cannot extend up to 2 o'clock. So whatever the doubts you have in the previous years or whatever the doubts you have in the last chapters, I'll be explaining those questions in the doubt clearing session, not during the class. Please give mu values for the different soils. So we don't need to go for the different soils. We generally discuss about the clays. So generally we go for mu as a 0.5 for soils. Sir, if the point is not in the center and not at the corner, if it's on the edge, then what should we have to do? Sir, we have to do as we have to cover it as a whole rectangle, sir. We have to cover the whole rectangle, sir, and at the end you have to remove that portion. You remove the Newmark's method, right? The same way. So immediate settlement is occurs only footing is flexible. No, see, given they did not mention as rigid, so that's the reason why I took as flexible. Homework answers sent. Or if I do send everything, then what will you do? I'm sending you solutions for the assignments. I'm giving the solutions for the GATE and IES and the classroom practice questions. Then what will you do? Tell me. I'll be provided all the homework questions at the end, not in between. Whether you like it or not, I'm giving you some work. I'm reducing a lot of work from your side. I'm giving you my own notes. I'm giving you the videos and I'm giving you a lot of resources. And from your side, what you're doing. Think, apply. That's it. Give me a minute, 1 minute. I'll be taking some water. So I didn't want to bought the water. Mr. SSMB, sir, X in the figure is at the center, na sir. That's not center, Nana. That's not center. See, why I took this as a corner is, you please observe, the given values of L by B ratio is I at the corner. I at the corner. So as they have given I at corner, so I took this point as a corner. So if I give you I at center, then I would be consider this value as a center. Then how come I take it as center, sir? See, for the center, you have to add extra portions like this. For the center, you have to add extra portions like this. And then you have to remove the extended portion also. So that's going to be quite complex. So you don't need to worry about that points over here. Look over the understanding of this point over here. That's it. You don't need to worry about the center. If they would have given the center, they won't give you the irregular data. They will give you the figures. For centers, they will give you the regular rectangle. Just like, see, they'll give you like this one, and they'll ask you I value. You know the L, you know the B, you find out the L by B, and what is the I value at center? You can find it out from that table. But as this point is going to be corner, now I have to see, if I say this is going to be corner, if I give you I at corner, then I have to divide into 4 rectangles. 1, 2, 3, 4. Then I have to find out for each rectangle. Okay. But they have given, if I at center, then I have to take it as a whole as one single point. So total settlement is elastic plus plastic. Yes, my dear Chavan. I'm trying, sir. Do try, my dear. It's very good of you. If you try, you have to try until Mr. Harish, today I wrote IAS exam. I solved 14 questions in 25 minutes. So it boosts my self-confidence. How to solve without calculator? Give me any suggestion. The only suggestion that I can give you is practice, practice, practice. Nothing. So please don't delete the video lectures getting doubts on the previous lectures. See, it was there for the past 2 weeks. Then what you're doing? What you're doing there? Do you get the same opportunity in the case of the offline classes? Can you see the yesterday's offline class today? No, right? But we are giving you an opportunity for almost 2 weeks for the same class. Primary consultation is for all kind of case. Mr. Aditya, sir, I am solving numericals easily, but I am finding difficulty in solving assertion and reason, which means you need to go thoroughly through the concept, Aditya. Okay, fine. Now, immediate settlement important for gate. Yes, it is important for gate. Yeah. Okay, fine. Now, let's get to the new chapter. So, with this, we completed the chapter number 11. Stop your questions. And now, let's start chapter number 12, compaction. Chapter number 12, compaction. So now, in the case of the compaction, see, I told you what is meant by compaction. Stop your questions and start listening. I'm telling you once again, this is the last time I'm going to say. So now, in the case of the compaction, in the previous sessions, in the previous compressibility chapter, I told you what is meant by compaction and what is meant by consolidation. What is the difference between the compaction and the consolidation? So let me explain those things again. Now, in the case of the compaction is a process of reduction in volume by expulsion of air. Yes. Whereas consolidation is a process of reduction in volume by expulsion of water. Expulsion of air process is compaction. Expulsion of water process is consolidation. And compaction is a short-term process. Whereas consolidation is a long-term process. Their time is more important. And compaction is a dynamic, whereas consolidation is a static. And one more thing, in the case of the compaction, no matter how much you compact, at the end, some amount of air will be left over. I told you that. And in the case of the consolidation, during the entire consolidation, degree of saturation is 100%. All these points I have mentioned you clearly in the previous chapter. So now I'm not going to say you the definition of compaction and is it a short term or long term. I have given you enough. Now, you know the meaning of compaction, but now I'm going to discuss why we require compaction. What is the necessity of the compaction? Where do we apply this compaction? So listen to me, the necessity of the compaction. Necessity of the compaction. See, while you are constructing an embankment or an earth dam, see, I want to construct a state highway. So for that I required an embankment. And I want to construct an earth dam. So for that also I required a soil mass. Yes. Again, whiteboard problem. What about now? Yes. Okay. Now, I hope it's working. I did not write anything. So I just wrote the necessity. That's it. I did not write anything beyond that. Now let's see. Look. So in the case of the in the case of the construction of an embankment and earth dam, first of all, we dump the soil mass in its loosest state. And then we are going to compact or not? Yes or no? Yes. So why, sir? Why means, first of all, to improve strength of soil and stability of slopes. Stability of slopes. To improve the strength of the soil and stability of the slope, we are going to compact, which means, for example, observe, now you see, whatever this is nothing but a highway. This is highway. And whatever this is nothing but the embankment, right? Yes or no? Embankment. So in this case, we are going to provide you different layers. This is subgrade. Here, subbase, base, wearing or top course. Wearing or top course. See, whatever this is nothing but an embankment or not. While you are going to fill it, you are going to compact the soil. Yes or no? Number one, to improve the strength of the soil mass, and you see it has some slope or not, to improve the stability of the soil mass also. So, and number two, to reduce the settlements. To reduce the settlements. Sir, why we want to reduce the settlements, sir? I told you in consolidation chapter also. Baba, if you construct your structure directly on a loose soil mass, what happens? On a loose soil mass means compressibility is more or not? Yes or no? Because voids are more. So if you construct your structure directly on loose soil, then the soil will undergo more settlement. But if you do compact the soil before the actual construction, if you do compact the soil before the actual construction, so due to compaction, the particles comes close to each other, which means the loosest soil now becomes as a densest soil. And in the case of the densest soil, if you construct your actual structure, then the settlements are going to be less compared to the structure on the loosest soil. So in the case of the construction purpose, means buildings, residential buildings or commercial buildings, we do compact it to reduce the settlements and to prevent uneven volume change. To prevent uneven volume change, which means swelling. See, you know that swelling means when the water gets imbibed between the particles. Have you remembered the absorbed water? when the water gets imbibed between the particles, the soil will undergo more increase in the volume. So these are our main necessity before compacting. So the necessity of the compaction is to improve the strength of the soil and stability, and to reduce settlements and to prevent uneven volume change. Now, my question is, Are sir, we understood the necessity, but how we are going to compact, sir? Sir, when you are going to compact, you need to know how much energy you are going to impart or not. You need to know how much energy is going to be imparted, and that depends upon whatever the test we are going to do. See, for the field compaction, first of all, we have to do a compaction test in the laboratory. I hope everybody have done the Proctor test in your laboratory. I hope so. So, because this is the test that you people do as a 4 to 5 people as a group in your laboratory, and especially for this test, in every group, there would be 1 or 2 girls in your group, and definitely they won't compact. They will allow the boys to compact, and the 2 ladies or 2 girls are going to be note down the entire details slowly while you are going to be compact and while you are going to give your effort. So that's true, because I have done the same thing in my college also while I was doing the compaction test. What I have done is, so there was a one lady, I mean my batchmate was there. So she used to yell at me always, and she's a topper. I am a loser, means I was not that good in studies during my BTech. So she used to yell at me every time when we have a batch. So while I was doing the compaction test, she was doing the same. And while I was doing the compaction, at one point of time, I slipped that compactor and I fell down the compactor or rammer on her foot. So fortunately, she had shoes. So that's the reason why she was able to walk. Otherwise, her foot would have been broken. So, don't do that in your, means if you have not done the experiment in your college, don't do that. Okay. So now, I hope you have done the compaction test in your laboratory, and there are different type of a compaction tests. So now, before doing the actual compaction in the field, we have to do the compaction test in the laboratory on the same soil, and we need to know when you compact, the particles are going to become close to each other. When the particles comes close to each other, the denseness of the soil mass is going to be increases. The denseness of the soil mass is going to be increases. And what is the maximum dry density that you are going to attain? So the test we are going to do is here as tests. So standard Proctor test are IS lightweight test. This is one test, and second one as modified Proctor test or IS heavyweight test. See the specifications for this test. Standard Proctor, IS lightweight is almost same. The specifications are going to be same. Again lagging. क्या रे भाई? Again. My internet is also good today, but why it is happening like this continuously? It is really Now, is it the same problem? Okay, fine. Stop, and I will be continuing. So there are these tests that we are going to do: standard Proctor test and modified Proctor test. The test results, whatever the test results we get from the standard Proctor test, we use these things in the case of the embankments, earth dams, and state highways. And state highways. I think it's going to be like 1 minute lag. You please wait for some time. So it will be coming. So don't worry about that. But you please wait for 1 minute. Once if it won't see for you, you please wait for 30 seconds. Then you can probably see those. So now the standard Proctor test results, whatever the results of the standard Proctor test, we are going to use in the case of embankments, earth dams, and state highways. And modified Proctor test, in the case of the modified Proctor test, we are going to use in the airport, runways, expressways, F1 race roads. See, the difference between the standard Proctor test and modified Proctor test is the difference between the standard Proctor test and modified Proctor test is compared to standard Proctor test. In modified, the compactive energy that you are going to give is more. Sir, why we need to go for the airport runways, sir? Sir, in the case of the airport runways, while a flight is going to be taking off, or while a flighting is going to be landing, while it is landing, it is going to be given a huge impact on the ground. Yes or no? When a plane is landing with such a high velocity, definitely it will impact a huge impact on the ground. And in order to take that huge impact, soil should be strong enough, which means you need to compact the soil mass at higher levels. Similarly, in F1 race roads also, you know that in F1 race roads, the speed with which the cars are going to be moved, and with that speed, the roads can easily undergo attrition and abrasion. So if you want to make sure the roads are safe, then you have to compact to higher levels. So higher compactive effort. Higher compactive effort. That is the reason why we use these results for the airport runways. Now, what is the aim of the test? The aim of the test we are going to see here is, number one, to determine, number one, maximum dry unit weight. Maximum dry unit weight, gamma D max, or we can call it as a MDD, means maximum dry unit weight. Okay. Maximum dry unit weight, MDD, gamma D max, or MDD. And second one is optimum moisture content represented with OMC. See, these are the two things that we are going to find out. One is maximum dry density and other one is optimum moisture content. Sir, why we add a moisture content, sir? Listen. See, in the dry state or when the water content is very less, the soil used to be very stiff, which means all the particles are the friction between the particles is going to be very high. Yes or no? Now, when I add some amount of the water, when I add a water content, then what happens? In between the particles, the water will imbibe over the surface of the particle. This is a particle. The water will imbibe over the surface of the particle. Then, due to the water between the particles, now the particles can move easily and they come close together as a whole. So, such a type of effect is known as a lubrication effect. Such type of effect is known as a lubrication effect. Okay, fine. What I do is I'll try to reconnect it once again. Please wait for that. Wait for that. I'm saving this one. I'm logging. I'm logging out. Wait for a moment. I'm going to recheck this one, please, because most of the time people are saying about lagging only. So let me recheck this once. Yeah. Okay, let's come to the things. So now, as our aim is going to be to determine the dry unit weight and whatever aim, maximum dry unit weight and optimum moisture content. Now let's come to the test procedure. So the procedure of that test. Let's hope the lagging won't appear. Test procedure. So what we are going to see in the test procedures are here. Again, in the case of the test procedure, you see for everything, I told you if I do an experiment, there are 4 things. One is aim, soil, apparatus, procedure. Aim is to determine MDD, maximum dry density and optimum moisture content. And second one is going to be the apparatus. soil. You can take any soil mass because compaction is not only for the cohesionless, it can be cohesive soil also. So you can use any type of soil. And the third one is apparatus and procedure. So what is the apparatus, sir? I hope you know the apparatus is going to be a circular cylindrical mold. This is a circular cylindrical mold. So this is a mold, and this is going to be connected to a base plate. This is going to be connected to a base plate. So this is a base plate. You have to connect this to a base plate. And not only that, what we are going to do is we are going to provide a removable collar. Yes. See, this is a mold. This is a mold which is going to be circular in plan. The plan is going to be circle only. So this is a plan view, and here it is going to be the section view. So now this is a mold which is going to be circular in plan, and in the side it is going to be cylinder. So circular cylinder, it must be having some diameter and it has some height. And apart from that, what we are going to do is we connect a removable collar. Whatever this is nothing but collar. So whatever this is nothing but a collar. And whatever the blue one I am representing now, this blue is going to be a mold. So we have a circular cylindrical mold which is connected to a base plate at the bottom and connected to a collar at the top. Now what we are going to do here is you take a tray. You take a tray. So this is a tray, and in that you keep some heap of soil mass. So this is a oven dried or air dried soil sample. See, whatever the soil that you are going to use, earlierly it should be oven dried or air dried, because we are going to add some more water content. Yes or no? Now what you need to do here is you make sure, now you please try to remember your procedure. You are going to make sure this soil mass into 3 to 5 portions. Yes, and you are going to add an arbitrary water content. Why? Because now you see, yet dry state or low water content soil is very stiff. Soil is very stiff, and particles won't come closer or and offers more resistance to compaction. More resistance to compaction. So if the soil is going to be dry state or at the low moisture content, soil is very stiff and offers a resistance to compaction. Why? Because the friction between the particles would be more. So it won't allow the particles to move easily. Due to more friction, particles won't move easily. Due to friction between particles, they means particles move easily. So at the dry state, now what we do is, as water content increases, particles will move easily due to lubrication effect. So due to lubrication of effect and compaction process easy. So the point why we are going to add the water content here is, if you add the water content, what happens is, what happens if you add more water, then imbibe over the top surface and the particles will move easily because the friction between the particles would be less. So as water content increases due to lubrication effect, lubrication means so the particles can slide over each other. The particles can slide over each other. Particles can slide easily due to lubrication effect. So now what we are going to do here is, now we are going to take some arbitrary water content, W in terms of percentage. Arbitrary means any value you can take. Any value you can take. W in terms of percentage. So let me go with the 5% of the moisture. See, I have taken some dried weight or not. Let's take the dry weight of the soil as 1 kg. Then what is the water content? You know, water content means weight of water by weight of solids. 5% is equals to weight of water by 1 kg. You can find out the weight of water. Yes. Now, what you do here is, so in the laboratory, in order to compact, there is a one device known as a compactor. There is a one device known as compactor. How does it look, sir? There is a one device known as a compactor or a rammer and you see whatever, this is nothing but a rammer. And now see, you can lift this one up to the total height. So whatever, this is nothing but the rammer, and that rammer definitely has some weight. So this is known as a rammer, and whatever the height it is going to be having, it is known as height of fall H. So I hope you have seen this rammer. So now that rammer, you see, whatever this is going to be a circular cylinder again, you can take the tip of that rammer and you can lift the rod. Whatever this is nothing but the rammer rod. And you can lift the rod up to maximum height of H. So now what we do is, we take some arbitrary water content 5%, we add the soil mass, and now already soil is going to be ready. Now what you do is, you fill that soil in layer by layer. So in the case of the standard Proctor test, we use 3 layers. In modified Proctor test, we use 5 layers. Now, once I use these layers, now what I do is, I fill in 1 layer. This is the first layer. Take the compactor and compact it. So you keep the compactor, you lift the rod, you lift the rod, you lift the rod. So likewise, you are going to give how many number of blows? 25 blows. How many number of blows? 25 blows. Sir, why only 25, sir? That depends upon the volume of the mold. That depends upon the volume of the mold. So generally, the volume of the mold in the compaction test, we take it as 1000 cc. 1000 cc means 1 liter. So now what we are going to do is, we divide this, listen to this point, we divide the soil into 3 to 5 layers. We fill the first layer. Now by the help of the rammer, you compact it over the rammer by giving how many number of blows? 1, 2, 3, 4, 5, 6, like that. You are going to give 25 number of blows. 25 number of blows. Now, this is the first layer. Similarly, you fill the second layer. Do the same compaction. Again, 25 number of blows. Similarly, you do the third layer. Again, you are going to give the 25 number of blows. Which means, now my question for you, definitely this rammer will be having some weight, right? The weight of rammer. There must be some weight of rammer. Now, when I compact, I am going to give you a potential energy. Yes or no? What is meant by potential energy? Weight into height. So for one blow, I am giving you an RC. If I drop a bottle, what is the energy it will impact? This bottle has some weight and it is falling from certain height. Yes or no? Similarly, I lift the rammer and I drop it. Lift the rammer, drop it. Lift the rammer, drop it. Whatever the weight of the rammer into height of fall, that is known as energy, compaction energy. Likewise, how many number of blows you are going to give for one layer? 25 blows. Likewise, how many layers are there? 3 layers. 3 layers means how many total number of blows? 75 blows. One blow, weight into height. 75 blows, 75 into weight into height. That much energy you are going to impart. Now, after this entire compaction, now this is going to be a compacted soil, right? This is going to be the compacted soil. Sir, after this, what I have to do, sir? Now you see, sir, you remove the removable collar, sir. You remove the removable collar. So that collar can be removed easily. When you remove the collar, some portion of the soil, see, this is the mold, right? Some portion of the soil will be above the mold. Now, what you do is, you remove the collar, you scrape off the top. You scrape off the top. You scrape up to this point, which means you remove up to that point. So remove the collar and scrape off the top portion. Scrape off the top portion. Remove the base plate. So base plate removed, collar is removed. Now, in the laboratory, there is a one device known as a mold extractor. Mold extractor or soil extractor. Now, if you keep that mold under the extractor, so if you press that extractor, soil will be coming out of the mold. And whatever the soil mass coming out of the mold, you can note down the weight of the mold as, note down the weight of compacted soil from mold as W. Now, then what is the unit weight of the soil? The unit weight of the soil. See, this is the weight of the compacted soil, not the normal soil. This is the compacted soil. So now unit weight is going to be weight by volume of mold. What is the volume of mold? Pi by 4 d square into h, or where d is the dia of the mold and h is going to be height of the mold. So you don't need to worry about that. So that's the volume of mold. I will discuss you that volume of the mold later. Now for this I'll be getting some unit weight, yes or no? And once you know the gamma value, then I can find out gamma D is equals to gamma by 1 plus water content. Gamma D. This is going to be 1 plus water content. So now, you see now, see coming to this point once again, at a dry state, lower water content, more resistance to the compaction. So increase the water content. Now let's take, I'm going to 10%. I'm going to increase the water content to 10%. Yes or no? Then the unit weight is also going to be increases. As water content increases, particles can slide easily due to lubrication effect and the compaction becomes easy. When the compaction becomes easy, what happens here is the particles will come close together, then the unit weight of the soil is going to be increases, gamma D also increases. And similarly 15% it is going to be increases and becomes easy up to certain moisture content. So compaction, becomes easy up to certain moisture content and attains maximum gamma D. So up to certain moisture content, the compaction becomes easy and gamma D will be increases up to certain moisture content. And beyond that moisture content, what is going to be happen is water replaces or water will taking space where solids should be and gamma D starts to decrease. Sir, what is the meaning of this one, sir? Sir, up to certain moisture content, what happens over here is the water acts as lubricant and the particles comes close together, dry density is going to be increased. And beyond certain moisture content, what happens is if the moisture content is more and more, now whatever the water you are adding is going to be taking the place of the solids. So in the given mold, you see, in the given mold, if water is going to be more, then the water place is going to be more than the solids. Compared to solids, unit weight of water is very less, such that the total mixture unit weight is going to be decreases. Then gamma D starts to decrease. So up to a certain extent, for example, up to 20%, gamma D is going to be increases. And suddenly, if I add 25%, the gamma D starts to decrease. And let me add 30%, the gamma D starts to decrease. So while you're taking the test, Means while you are conducting the test, what you need to look over here is you need to add the water. At initial water contents, gamma D increases, and then later beyond certain moisture content, the gamma D starts to decrease. Why it is going to be decreases is moisture content water, or water will take place. Sorry, water will be taking place in the space where the solid should be. So this is the process of the compaction. Now, once we attain this data, water content and gamma D, water content and gamma D, now compaction curve. So what is this compaction curve, sir? On the x-axis, water content in terms of percentage. On the y-axis, gamma D. On the x-axis, water content in terms of percentage. On the y-axis, gamma D. So now, what we are going to see here is, you observe from the data, initially, as water content increases, gamma D increases, and beyond certain moisture content, gamma D starts to decrease. See, I have written every point over here. You please go through these points. So now, initially, as water content increases, gamma D increases, which means the curve should look like this. Yes or no? And this gamma D will reach a maximum. The gamma D will reach a maximum, and then it starts to decrease. And then it starts to decrease. So now, if I draw the curve exactly, so this is going to be the curve that we are going to attain. And this curve is known as a compaction curve. As water content increases at first, as water content increases, gamma D increases up to certain extent, and whatever the water content at these points, I was saying you up to certain water content or not, and that certain moisture content is known as optimum moisture content. And whatever the unit weight that we attained at this point, this is known as maximum dry unit weight. That is known as maximum dry unit weight. So now, beyond OMC, beyond certain moisture content means beyond that moisture content. Now I will be writing that beyond OMC, water will taking space where solid should be, and gamma D starts to decrease. Gamma D starts to decrease. So now, what is meant by OMC? OMC means moisture optimum moisture content at which maximum dry unit weight attains. So now my question for you is, listen to me carefully. Practically, in reality, the removal of 100% of air voids are not going to be possible. You know it, I told you earlier also. So practically it is impossible to remove all the air in the voids. It is impossible to remove total air in voids, which means practically AC cannot be zero, NA cannot be zero. What is AC? Air content. What is NA? percentage air voids. So practically, whatever the unit weight we attained over here is practically gamma D is equals to 1 minus NA into G gamma W by 1 plus W into G. Practically 1 minus NA into G gamma W by 1 plus W into G. I'll write one more point over here. You know that when SR is not is equal to be 0, then when AC is not is equals to 0, then SR is not equals to 100%. Because you know that, or I'll write in this way, AC greater than 0, NA greater than 0, and SR less than 1. SR is going to be less than 1. So practically, you cannot achieve 100% removal of air voids. So the percentage air voids, if I take, that is going to be NA, 1 minus NA into G gamma W by 1 plus W into G. I explained this equation in chapter number 2. If you have remember, you please go through that. There is one more equation, gamma D is equals to G gamma W by 1 plus E, but this equation is going to be modified as, from Sehwag. You know that Sehwag E into SR is equals to W into G, right? Can I write E as a W into G by SR? So, but practically, you know that just now I said, practically in this SR is less than 1 and in this NA is greater than 0. This is a practical condition. So in the case of the practical condition, this is how the gamma D is going to be find out. But theoretically, theoretically, 100% removal of air voids can be achieved. This is theory only, and this is practical, which means NA is equals to 0. Then AC is equals to 0. Then what is SR? 100% or 1. So now in the same equation, now you please observe whatever the equation I have written. Gamma D, now this is going to be theoretical. Can you keep NA is equals to 0 now? Can you keep NA is equals to 0? So now this is going to be G gamma W by 1 plus W into G, because NA is equals to 0. Or gamma D theoretical is equals to G gamma W by 1 plus W into G. Here you can write from the both equations, you can write over here. G gamma W by 1 plus WG. NA is equals to 0 or SR is equals to 1. If you keep SR is equals to 1, what is the value? SR 1, then G gamma W by 1 plus W into G. If you keep NA 0, then what is the value? Gamma D, G gamma W by 1 plus W into G. So this is practical and this is a theoretical. And this graph is a practical. This is a practical evolution. That is the reason why it starts to increase and then it starts to decrease. It starts to increase and then it starts to decrease. Now my question for you, think and tell me, which unit weight is going to be more? Which unit weight is going to be more? Gamma D theoretical or gamma D theoretical or gamma D practical? Always gamma D theoretical is more than gamma D practical. Because if you observe in this 1 minus Na, if Na is going to be more, if Na is going to be more, if Na is going to be more, then gamma d is going to be decreases. Yes or no? Because numerator is going to be less than 1, but here numerator is going to be 1. So always gamma d of theoretical is more than the gamma d of practical. Mr. Anonymous attendee, why dry unit will decrease at OMC? I have given you clear explanation here. Where were you? I have given you clear explanation over here. You please see that. Beyond moisture content, OMC, water will take space. Water will be taking space where solid should be. Where solid should be. If you add more water in the mold, if you add more water in the mold, means in the mold, instead of solids, more amount of the water will sit. When the water will sit, then you know that the total unit weight is going to be less. So now, sir, modified Proctor test is better in all aspects than standard Proctor test. Then why don't we use a MPT? See, Baba, not only that you know that, we have to go for economically also. If you go for modified Proctor test results, then it is not going to be economical. So modified Proctor test results are going to be used wherever it is actually wherever it is going to be required. Until or unless you only go for the standard Proctor test. So as an engineer, we have to look over one aspect, cost aspect also. Now, always gamma d of theoretical is more than the gamma d of practical. So with this, now let's come to the graph. For the same OMC, this is gamma d max and practical. For the same water content, yet same water content, always gamma d of theoretical is more than gamma d of practical. This is OMC, and for the same moisture content, this is going to be the gamma d. This is theoretical, and this is gamma d practical. So yet OMC, gamma d max is equals to G gamma W into 1 minus 1 minus Na into G gamma W by 1 plus W, water content at OMC into G. And gamma D theoretical is equals to just G gamma W by 1 plus water content at OMC into G. I hope you understand this equation. Now you tell me, at OMC, the gamma D max is this one and gamma D theoretical is going to be this one. Yes? Now, if you observe here, come on, everybody have a look over here in this equation. I want you to understand this equation. Here, what is the numerator, please? G, constant, gamma W, constant, and gamma D varies with respect to whom? Water content. And now, with this, can I say that theoretical is going to be like, as water content increases, gamma D decreases. From the theoretical perspective, as water content increases, gamma D decreases. Is it theory or practical? Theory. Because in the case of theoretical, the numerator G is constant and denominator is gamma W is also going to be constant. But in the case of the practical, you see, in the case of practical, as water content changes, then the number of percentage air voids also changes. So this is going to be varies, this is going to be varies. Numerator changes, denominator changes. That's the reason why practically the curve increases and decreases. Whereas in the case of the theoretical, the numerator is going to be constant and the denominator is going to be changes. As water content increases, gamma D is going to be decreases. So by using this logic, so as water content increases, whatever this line, see this is going to be the C. For this water content, this is a practical. For this water content, this is practical and this is going to be theoretical. So now with this, if I join all those points, then I am going to get one more curve. one more curve, and this is a gamma D theoretical, and this line is known as zero air void line or 100% saturation line. So, sir, why this zero air void line is going to be falling continuously? Why this is rising and falling, sir? Because in the case of theoretical, see, this is theoretical one. This is theoretical and this is going to be practical. So, in the case of theoretical, gamma D as a water content increases, gamma D decreases directly. That's it. No option. But in the case of practical situation, as water content changes, Na is also going to be changed, then gamma D changes, both increases and decreases. So that's about the theoretical and practical conditions. So now with this I have explained you how the compaction is going to be done and how to determine the maximum dry unit weight and what is the moisture content at maximum dry unit weight. What is the moisture content? Optimum moisture content is the maximum water content at maximum dry unit weight attains, but practically you know air voids cannot be zero, but theoretically I can take air voids can be zero. This is Na. What is meant by Na? Zero air voids or 100% saturation line. Now you see, I'll ask you one more question. Note, does see 100% saturation line and zero air void line are identical? Now the question is, does 90% saturation line and 10% air void lines are identical? See, this is the question mark I am saying you. Does 90% saturation line and 10% air void line are identical? See, 100% saturation line and zero air void line are identical, right? So now I'm asking you, does 90% saturation line and 10% air void line, does these are going to be identical? Please tell me. No, they are not. Why? Why they are not going to be identical? You see the solution. You see the solution. They are not identical. Identical means whether they are same or not. Why, sir? So what is the meaning of 90% degree of saturation, sir? SR is equals to 90%, sir. You know that SR plus AC is equals to 100%. So from this I can write AC is equals to 100 minus 90, which is going to be 10%. Yes. Then what is the percentage air voids relation? Na is equals to N into AC. I hope you remember everything. What is Na? Percentage air voids. And what is AC? Air content. What is N? Porosity. Where N is porosity. The range of porosity is range of N 0 less than N less than 1. So now Na is equals to N into 10%. N into 10%. As you know, the porosity range is less than 1. As you know, the porosity range is going to be less than 1. I'm telling you, as you know, the porosity range is going to be less than 1. Lesser 1 into 10 then Na would be less than 10%. Because as the range of N is going to be less than 1, then if you apply, then less than 1 into 10, the value is going to be less than 10%. So degree of saturation 90% and percentage air voids are going to be less than 10%. I can say 90% saturation line is not equals to 10% air void line. Percentage air voids, right? I hope you understood the meaning behind this. So now, see, this is about the values of gamma D and whatever the curve. See what I have presented some points over here. This curve is known as compaction curve. This is not the end. There are some things that we need to know it. Now you see, I was explaining you continuously. This compaction is going to be done. This is not a linear line. This is non-linear. Mind it. This is non-linear. This is not a linear line. Means the curve is not a straight line. It is going to be having some curvilinear shape. So that is a non-linear shape. And please note that in your mind. Now, I'm using this rammer, right? I'm using this rammer. And there is some height of fall. And there is some volume. So I will note down one more point over here also. So number of blows are right at this end. So now, as I know different type of tests are there, what I do is I'll take the quantities into the consideration. In many books, zero air void line is straight. No, never it is going to be a straight line. Please keep that in your mind. So now I will discuss the quantities. You don't find gamma D by using formula, not the present formula. Why we use gamma D is equals to gamma by 1 plus W, you know, sir. Why to compare gamma D is equals to G gamma W by 1? Arey bhaiya, wait for bhaiya. This is gamma D for finding from the test, Nana. But from the results, whatever the values, you need to know, means you know that there is some air voids are there. If you want to find out some air voids, you have to use this relation only. You have to find out some air voids, then you have to use this relation only. Normally, this is the equation. Yes. So now, parameters. Whatever the parameters, now the tests are going to be standard Proctor test, modified Proctor test, IS means Indian standard, lightweight test and IS heavyweight test. So now I am providing you volume. First of all, what is the weight of the rammer, height of fall, weight of rammer, height of fall, number of blows, number of volume of mold, number of layers, and number of blows. So I want to know for all these tests what is the weight of rammer, height of fall, volume of mold, and number of layers and number of blows. So now let's see what are those. In the case of the standard Proctor test, the weight of the mold is going to be 2.6 kgs, and for modified Proctor test 4.9 kgs. 2.6 kgs, and for modified Proctor test 4.9 kgs. And in the case of the IS lightweight test, this weight is going to be 2.495 kgs, and here it is going to be 4.54 kgs. See, you observe over here, this standard Proctor test weight and IS lightweight test almost similar, right? Almost the values are going to be same, 2.495 and 2.6. This is 4.9 and this is going to be 4.54 kgs. Because I am giving all the values, because in state service examinations, they will be asking this IS lightweight standard separately. I told you earlier, the standard Proctor test and IS lightweight test are almost similar to each other because their compactive effort is going to be almost similar. So let me write that first once again. This table is important for GATE or ISE more. This is important for GATE, IES, and state service examinations also. Now, what is the height of fall, sir? So generally, in the case of the standard Proctor test, the value is 310 mm. 310 mm. And in the case of the modified Proctor test, 450 mm. But in IS lightweight test, 304.8 mm, 457.6 mm, 457.6 mm. See, I used to remember it as a standard Proctor test 31 centimeters and modified Proctor test 45 centimeters. So I am writing it in terms of mm. Now the volume of mold in standard Proctor test and in modified Proctor test is 1000 cc, and in the IS lightweight test 944 cc. 944 cc. So 1000 cc, 1000 cc. This is going to be 944 cc. Yes, it will be seen, it will be seen. Don't worry about that, it will be seen. Now, the number of layers in the standard Proctor test is 3 and in modified Proctor test is 5. In IS lightweight is 3 and in modified means IS heavyweight is going to be 5. And the number of blows are going to be 25, 25, 25. This is going to be fixed. This is going to be fixed. So generally, the number of blows depends on volume of mold. The number of blows depends upon the volume of mold. No, it's not a relation between the soil type. It is Indian standards, Nana. This is according to Indian standard. This is a modified Proctor. So Proctor is a scientist, is an American scientist. Mostly we use American standards. So there are some Indian standard also, but you see there is a slight change. That's it. The standard and IS lightweight are almost similar to each other, and modified and IS heavyweight are going to be almost similar to each other. You please observe, there is very less difference between these two. These two are going to be almost same, and there is a less difference between the IS heavyweight and modified, almost same. So these are the values that you need to remember for especially ESC. Thus, foundation engineering will be continued after shear strength, yes, and it will be continued in online session, yes, not offline, so don't worry. Yes, you need to remember these values for the gate. You please refer the textbooks, Mr. Ame. Sir, you mentioned both standard and lightweight are same, but why rammer weight is different? Because see, I said same, similar, but not exactly same. There is a small change over here. That's the reason why I have given. So number of layers also depends on mold itself, sir. Sir, the mold means what, sir? The volume of the mold only, sir. Why can't you teach one more subject for us that we'll see later? Now, sir, is the weight of rammer including the external barrel also? No. Sir, when it will be possible to conduct the classroom coaching? It won't be possible as of now because of the lockdown restrictions and all those things. What, Mr. Karthik BVRIT? What do you want? You will write or you wrote your name now. Yes, the number of blows are same in both tests. See, it is going to be same. So now, yes. Yes. So now, Taylor's tricks means if you remember standard and modified, then you can remember IS and IS heavyweight. Now, compaction effort. Compaction effort. Compaction effort is nothing but the number of layers into number of blows into weight of hammer into height of mold by volume. By volume. So number of layers by V means where N is number of layers, capital N number of blows, W weight of hammer, and V volume of mold. Volume of mold. So these are the values. I just gave you all the things. Now you tell me for standard Proctor test, for standard Proctor test. So compact effort is equals to, what is the number of blows over here? The number of layers are going to be 3 into blows 25 into weight 2.6 kgs. That we call it as a rammer, not a hammer. Hammer is different and rammer is going to be different. So the impact, if the blow, the rod will lift and fall. That is going to be rammer. And hammer is a single blow. You are going to hit it. Are you going to hit it with a hammer? So hammer is a huge impact, Nana, that we don't use in the laboratory. We call it as rammer. Sorry. Weight of rammer. So now into height of fall. What is the height of fall I have given you? The height of fall is going to be for standard Proctor test as 310 mm. 310 mm. So now this is mm. I can write in terms of the meter, 10 to the power of minus 3 meters, Nana. And what is volume I have given you? 1000 cc into 10 to the power of minus 6. What is the meaning of 10 to the power of minus 6? This is going to be in terms of the meter cube, because 1 cc is equals to 10 to the power of minus 6 meter cube. So now you please find out these values and you please tell me. 3 into 25 into 2.6 into 310 into 10 to the power of 3 . That's it. So which is going to be 60450 kg per meter cube. 60 means 60,450 kg per meter cube. Now similarly, for modified Proctor test, see, you don't need to remember this value because you can solve it, right? Even I don't remember these values because I can solve it. For modified test, now 5 into 25 into 4.9 into 450 into 10 to the power of minus 3 by 1000 cc into 10 to the power of minus 6. This is going to be meter cube. So similarly, you can find it out now. 5 into 25 into 4.9 into 450. So which is going to be 2,75,625 kg per meter cube. So you are going to give 1 meter cube, the impact is going to be 2,75,625 kgs. So now the energy ratio, the last one I want to say over here. See, this is all the discussion that we made because these points are very, very important and it has been asked in previous IES and GATE. Energy ratio. Energy ratio is equals to compactive effort in modified to compactive effort in standard. Or similarly, sir, why you are taking only modified and standard? You can go for IS lightweight and IS heavyweight also. I don't have any issue, that I am leaving to you. So now that energy ratio ER is equals to compactive effort in modified. What is the value, please? 2,75,625 by 60,450. So can you please tell me what is this energy ratio? By 60,450, which is going to be 4.56. So now the meaning of this one is, again lagging. Yes, see, there is nothing I am discussing as a concept over here. Okay. kg. See, the units are going to be over here as kg meter per meter cube. Please have done kg meter per meter cube. And you can convert that into joules also. If you multiply with the joule, So if you want to write in terms of joules also, you can joules, you can write down that in terms of joules also by multiplying in 9.81. So the meaning of this energy ratio is, you please observe what is the meaning of 4.56 is see, the compactive effort in the modified is a 4.56 times more than the standard. The compactive effort in the modified is 4.56 times more than the standard. So these are the values that I want to give you separately, or you can directly take it as a ratio also. So because why I give this one is I will be using this one later in the case of one problem, gate problem. So wait for that moment. Now, one more point. As I told you, number of blows depends upon the volume of the mold. I will be erasing this point over here, and because I will be discussing again over here, number of blows depends on volume of mold. Generally, for 1 liter capacity, which means 1000 cc, the number of blows are going to be 25 blows. So in one of the previous IS examination, if instead of 1 liter, if I go for the 1600 cc, what is the number of blows? See, I can understand for 2.25 liter mold, then what is the value? See, for 1 liter it is going to be 25. For 2.25, 2.25 into 25, you please find it out. 2.25 into 25, which is going to be 56.25. As we cannot give this 0.25 blows, we can take it as 56 blows. And for if I ask you 1.6 liter, 1.6 liter means 1600 cc. See, generally this is the concept, and if you know these values, you can apply these values for anyone. You can apply these values for anyone. For 1.6 liter, for 1.6 into 25, so then 1.6 into 25, the values are going to be 40 blows. So depending upon the volume of the mold, see, in the case of California bearing ratio test, CBR test, I hope you have done in a transportation engineering laboratory. There, the mold volume is 2.25 liters. So for the 2.25 liters, then you are going to go for 56 blows. What is H? H means height of fall. Height of fall. So number of molds and everything. So again it is lagging. Okay, fine. And if it comes now let me explain once again. I have written everything now. Please have a look. Yes, I hope everybody has able to see now. Please have a look. I'll be explaining. Don't worry about that. See, the compaction effort means this is the compaction effort means you know that for a given blow, what is the weight W? What is the energy you impart? W into H. Yes, W into H. And likewise, how many number of flows you are going to give N? Likewise, how many number of layers? Small n. Per unit volume. Per unit volume. So that is the compaction effort that we are going to mention. Now, for standard Proctor test, if you apply, what is this value? This is the value. For modified, this is the value. And the energy ratio means it's a ratio of modified to standard. So after solving, it comes as 4.56, which means compared to standard Proctor test in modified, we are going to apply an energy 4.56 more times. 4.56 more times. And now, coming to the number of blows, generally the number of blows depends upon the volume of mouth. In 1 liter, 25 blows. Sometimes in an examination, they will ask you, instead of 1 liter capacity, if a 2 liter capacity of mold is used in a compaction test, what should be the number of blows? If a 1.6 liter capacity of mold is used in place of the 1 liter capacity, what is the number of blows? These are the type of question. One of the previous ESC question is, instead of using 1 liter capacity of mold, if we use 1.6 liter capacity, then what is the number of blows that we need to impart during the test? So if I use 1.6 liter capacity, then you have to go for the 40 number of blows. So this is what the explanation I have made. And now let's have a break. And after the break, I am going to discuss what are the factors affecting the compaction and what are the factors affected by the compaction. So meanwhile, I'll try to resolve this lagging problem. So now have a break and come by 11:25. Let's say 11:30. Come by 11:30. It's almost 11:10. So come by 11:30. Okay, come by 11:30. let's come back to our session. Hope people are there here. So still they have to come. And meanwhile, want to say, see in India right now, the cases are increasing like anything. So you know that in most of the places, lot of relaxations has given. So keep that in your mind. The government has not able to do anything as long as the vaccine is going to become. And we know that from the past 2 months, we are under lockdown. So obviously, the economy has been collapsed. Already the economy of our India is very less. And now it has been collapsed like anything. So they don't have any other option. So to have let the business to run so that they can gain some income from the business. So especially from the alcohols and whatever the remaining things also. But yes, WHO declared the vaccine for COVID is not possible. See, right now there are 7 vaccines are preparing in various countries. So I already told you, and Britain and America is in a race, and even India is in a race to prepare the COVID vaccine, but it will take time. So, I mean, according to the resources and according to the things that I got to know, by September, we can able to get the vaccine, but probably means if it is going to be applied for the more number of people, because before releasing a vaccine, they have to test a number of times on various people's aging from small age to, old age, and gender, like men and women. So they have to take a lot of things into the criteria, and they have to do a lot of survey, and based upon that only they can release the vaccine. So as of now, whatever we see, hydrochloroquine, or somebody is saying that arsenic, that is arsenic 30 cc, that's not true, that's a fake one. So don't think about that arsenic albium and something like that. And so right now, but alcohol is banned in some states, and in Gujarat only, but mostly, you know that in Telangana, you know what, 90% of the people is now vegetarian, and more than 80% of the people will have booze. So me from West Bengal, there are 13 people corona positive. So number of tests are very less in Telangana. Yes, that's there. According to you, reopening everything in Hyderabad possibly leads to many cases. Definitely it will lead to many cases, because see, if there is, we don't know up to the 14 days whether we get the COVID or not, because I may be potentially COVID also, because I don't know until the 14th day appears, and even that beyond that also, until or unless we do test, then only we can say there is a COVID. The patient has been gone through this COVID. And even this Arogya Setu app also, they can say based upon the symptoms. They can say just based upon the symptoms. We cannot rely exactly on the Arogya Setu app also. And while you're using the Arogya Setu app, please be careful, because a few days back there was a breach happened in Arogya Setu app. More than 90 million people in India, 90 million people, which means 9 crore people have enrolled in Arogya Setu app, and the hackers will hack the information easily. And there was a security breach happened in Arogya Setu app in 10 days before. So while you're using something, you please make sure yourself and you please, you know that in the Bangalore issue, it was like a Indian Air Force pilot flight. So that has created a sonic boom, and that sonic boom sound can be heard for 60 to 65 kilometers also. So whatever the sounds that has been heard by the Bangaloreans at around 1 to 1:20 p.m. in afternoon, that was the sounds of IAF flights. So due to that sonic boom, the sound can be resounded, means echoes will be there for the next 60 to 65 kilometers range would be there, the echoes. So that sound was that only, it was not from aliens or something else. Sir, institutions will open after 31st May, the hopefully, but education institutes will take some time, because most amount of the crowd will be there in education institute, be it the school, our colleges, our coaching centers. So it depends. It depends. We never know what the decisions that the government will take. So we'll see that. Yes, even Zoom was hacked. सिलेबस कंप्लीट होगा क्या सर, एंड बुक्स की फीस रिटर्न होगी क्या? अरे भाई, आपको आई मीन आपका पूरा फोकस सिलेबस का कंप्लीशन और बुक फीस का रिफंड नहीं है. अरे मींस यू आर नॉट फोकसिंग ओवर व्हाट इज हैपनिंग इन दैट. So not only the subject, see, I mean, what I feel is, when you are learning something, not only the subject, you have to learn something from the outside also. You have to think out of your boxes. So we are here when we are seeing everything that is happening around you. So you please know to know that whatever the some things that is happening around you, you need to know. You don't need to, means you cannot, see, even I am discussing all these things is, sir, can you make a vaccine for the COVID? No, I cannot. But what I know is, by knowing this type of information, we can make sure ourselves to confine what is exactly happening in the world, to make sure ourselves are to be in safe place, to make sure our family to in a safe place. So engineering examinations, we cannot say. Okay, fine. So I hope people have been keen. So, I mean, I took some period of time, so to make sure yourself. Got to know that you are a bodybuilder in Hyderabad too, sir. No, I am not a bodybuilder or something else. I'm just a faculty. Okay, fine, 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 fine. Okay. So now let's come. So people are there. So now let's start our session. Now let's see what are the factors affecting the compaction, and then we will be discussing about what are the factors affected by the compaction also. At first, the first one is going to be water content. Water content. So the water content, as you know from the previous, you know that from this one, as the water content increases up to a certain extent, dry unit weight increases and then it starts to decrease. So due to lubrication effect, gamma D will increase up to optimum moisture content, and beyond optimum moisture content, water will taking the space where solids should be, and as unit weight of water is less than unit weight of solids, because the solids are going to be replaced with water, right? Then gamma D starts to decrease. So the first one is water content. Number one is going to be the water content. Okay, still there is a board lagging. What I can do. See, what's the problem? I don't know. What can I do now? Today it's very difficult. I think I need to have one more connection. Actually, my broadband width is also good. It's a 50 Mbps per second. So, but I don't know why this problem is attaining. So let me go through once again. I'll restart. You please keep some time, please. So I'll restart once again. So that let's see. I already saved this. I already saved this one now. Let me leave once and I'll open this one. I have been reopened this one. So now, first one. Factors affecting compaction. So what are the factors that affecting the compaction? Number one, water content. So you know that in the case of the water content, whatever I have been discussed, I will just write that as water content increases due to lubrication effect, gamma D increases up to OMC, and beyond OMC, water will be taking space of solids and gamma D starts to decrease. I hope now there is no lag. So now Let's see the next one. The next one is compactive effort. So I just explained the compactive effort. I just explained the compactive effort. In the case of the modified Proctor test, the compactive effort is a 4.56 times more than the 4.56 times more than the standard Proctor test. So then what happens, sir? Sir, if I draw the compaction curve, you know, there is nothing but a water content, and here is going to be gamma D. If I draw the compaction curve, this compaction curve, if I attain, this is for the standard Proctor test. For the modified Proctor test, you can see, for the modified Proctor test, see whatever I have written, this is for the standard Proctor test, because in the case of the standard Proctor test, a compactive effort is less. So when you apply less force, then the compaction is less. Then compared to standard, in the case of a modified, Proctor test, we are applying more amount of effort. When you apply more amount of effort, then the particles will come to each other more and more and more. Then the density is going to be increases, and whatever the moisture content you need to add will be decreases. So if you see, this is the dry density over here, and this is the dry density over here. So now, higher the compactive effort, which means if you apply more compaction, then higher the dry density. And if you see the moisture content over here, and you observe, this is a OMC. So now, compared to standard, modified Proctor test, OMC is less. So now, I can write a point here as higher the compactive effort, higher the MDD. What is mean by MDD? Maximum dry density. Maximum dry density, and lower OMC. So when you improve the effort, then the dry density, maximum dry density will be increases, and lower OMC will be decreases. Let's say this curve as 1 and this curve as 2. You can see gamma D max at 2, and I don't need to write this one because you can understand this one instead of writing so the compactive effort is also going to be changes the compaction. Now let's see the third one. The third one is type of soil. Type of soil. So in the case of the type of soil, you see, coarse grain soils has more density. Yes or no? Coarse grain soils will have more maximum dry density, than fine grain soils. And one more thing I want to represent over here is clays. See, in the case of the clays, you observe, see, I said your fine grain soil is clay or not? Again in clay, as plasticity increases, you remember the plasticity, I hope you remember the plasticity and consistency limits. See, if the plasticity is more, consistency is less. Consistency less means then the denseness is going to be less or not? So in clays, maximum, in clays, MDD will gets lower with increase in plasticity. With increase in plasticity. So now, sir, why it is going to be plasticity, sir? What is the reason between the plasticity and compaction, sir? Sir, if you remember, in the case of consistency chart, plastic state occurs beyond shrinkage limit. Yes or no? Are beyond shrinkage limit, swelling is going to be happen na? When volume is more, the density is less. When volume is more, the density is less. So if the plasticity is more, then soil will undergo more compression, and that dry unit weight you are going to attain which be much lesser. Heavy clays with high plasticity will have least MDD. So now what I want to write over here is, let me represent that. So water content in terms of percentage and gamma D. I'll be providing you some graphs. Now, see, I told you coarse grain soils will have a more maximum dry density than the fine grain soils. Now, you see, this is going to be CH. What is meant by CH? What is meant by CH? CH means clay with high compressibility or plasticity. Clay with high compressibility or plasticity. And what about this one? Then it can be written as a Cl, because compared to, see, this is clay and this is clay. Compared to H, the low compressible, see, as a plasticity decreases, the dry density will be increases. And now I can write this one as a silty clay, and this is going to be like sandy clay, and this is going to be like well graded gravel. Well graded gravel. So if you observe, not only the soil mass but also its plasticity will be matter. Not only the soil mass but also its plasticity will be matter. Okay. So now I can say from these points, coarser the soil, higher the maximum dry density and lower OMC. Coarser the soil, higher the maximum dry density and lower the OMC. So you can see the clay will have a very low maximum dry density because of its plastic nature. So you please remember the consistency chart. You can see if the plastic state is more, then the consistency will be less, then the density of the soil would be very less. I hope you remember those. Now, if you observe, whatever these lines, I want to say one more point over here. If I draw a line, this is optimum point and this is optimum point. If I draw a line by joining these optimums, this is known as optimum line. What does it mean by optimum line? The line joining the optimum points. And you see, what about the zero air void line, sir? This is above the compaction curve. Mind it, this is optimum line, and above is going to be the this is zero air void line. That is zero air void line. Sir, if the dry density of coarse soil is less, who said dry density of coarse soil is less? I said dry density of coarse soil is more. Please look over the question. Sir, please show the slides. I cannot show the slides now because I have been created new thing. I have saved those. So now, if you observe clearly, have I said any pure sand? Have I said any pure sand? No. See, whatever the shape of the compaction curve, we call it as a bell shape or inverted U shape. Whatever the shape, note, shape of compaction curve is bell shape or U shape. Inverted V shape. See, that is inverted V shape. So now, see, if you observe, I have represented clay, silt, and sandy clay or sandy silt, well graded. But I did not mention you the sand. Yes, I did not mention you the sand. See, in the case of the pure sands, you are not going to be see the same shape of bell curve. Now, in the case of sands, there is a one phenomena known as bulking of sand. What is that? Bulking of sand. And you can see this. Bulking of sand. So what is meant by bulking of sand, sir? The bulking of a sand means, see, for pure sands, compaction curve is not bell shape. Then what is the shape of the compaction curve, sir? In the case of the pure sands, first the curve is going to be decreases, reaches a minimum, and then increases, and then decreases. See, this is the bulking of a sand. So what is meant by bulking of a sand? See, in fine sands and silts, water is under capillary tension. Water is under capillary tension. See, what I want to say over here is, now, in the case of the fine sands and silts, have you remembered the capillarity? Capillarity can be seen mostly in fine sands and silts. Yes or no? In fine sands and silts, water is under capillary tension. And due to this capillary tension, what happens is particles won't slide and comes closer, results in increase of volume and decrease in gamma D up to certain moisture. See, initially in fine sands and silts, water is under capillary tension. So due to this, the particles won't slide, Nana. They won't slide that much easily. As they won't slide easily, the increase in, see, the volume of the soil will get increases Because the particles are not moving, in the void space, who will be there? Water. And the volume of the soil will be increases, known as bulking of sand. So results in bulking phenomena. The point I want you to look over here is which one is going to be responsible in the case of which one is going to be responsible for this bulking is a capillarity. So due to capillary tension, the water won't slide, means the solids won't slide, and whatever the water you added will fill the void spaces and the volume is going to be increases. So now at first the volume is going to be increases, which means a decrease in the gamma D. The gamma D decreases and reaches to minimum. And this value is going to be 4 to 5%. 4 to 5%, which means I can write bulking of sand occurs up to 4 to 5% of water content, and beyond 4 to 5% of water content, then packing of particles occurs, results in increase in gamma D. So this is the reason behind the bulking of sand. If they don't come, so and comes closer, won't slide. Sorry. And don't comes closure. Sorry, it's not comes closure and don't comes closer. When they don't slide, they won't come closure. So results in increase in the volume. Now that's about the bulking of sand. Sir, in the case of the gravel, why the OMC is going to be less, sir? Sir, in the case of gravel, already density is going to be more, sir. If you add more water, what will happen, sir? The soil will behave like a liquid, sir. So in the case of the gravel, if you add small amount of moisture also, then the particles will orient and it attains more dry density. You please have a look once. So due to capillarity, it won't allow the particles to slide. Then the water won't slide and don't comes closer. And the particles don't see, these are the particles, right? You see, I'll be showing you. Let's say these are the sand particles, Nana. Let's say these are sand particles. And now, if you observe, whatever the film I am going to provide over here, this is going to be the water film. You please look over here. This is water film due to capillarity. So now you observe at 4 to 5%, what is going to be happen? So now, if these are going to be the solids present, then due to capillarity, it is going to be create a film over the top. So now, if you observe, these are solids and this is a water film. Water film due to capillarity. So due to this, what happens? Then the resultant volume of the soil will increase or not. So due to resultant volume of the soil increases, then the gamma D is going to be decreases up to certain moisture. Such a phenomena is known as bulking phenomena. And it will be happen in the case of fine sands, not in the case of coarse sands also. It will be happen in the fine sands and probably silts also, but we can see mostly in fine sands. So these are the factors, some of the factors that affecting the compaction. So how many times I said Ray, but capillary is more in clay, sir. Sir, capillary is more in clay, but due to low permeability, it won't occur that much easily, sir. So don't worry about that. Sir, why 4 to 5% we take, sir? Sir, we did not take that 4 to 5%. Up to 4 to 5%, it is going to be happen because this bulking happens at a low. Bulking of sand occurs at low moisture content and beyond 4 to 5%, what happens is a capillary film will break down. See, beyond 4 to 5% of water content, packing of particles occurs, results in increase in the gamma D, and capillary film will break down. So when the capillary film will break down, then there is no bulking. So now that's all about the bulking of sand. And now let's see what are the factors, some of the factors affected by the compaction. Now, factors affected by compaction. Factors affected by compaction. So what are the factors that affected by the compaction? Number one, shear strength. Number two, permeability. 3, swelling potential. Shrinkage. Soil structure. Soil structure. So these are the some of the factors that got affected by the compaction. Now let's see one by one. Look. Once you draw the compaction curve, once you draw the compaction curve, this is the water content and gamma D. So if you see, this is a compaction curve, and you can observe whatever this is nothing but line of optimum, right? This is optimum, means optimum. Now everybody have a look. See, this is for a given soil mass. For a given soil mass, as the water content increases, on one side gamma D increases, on the other side gamma D decreases. Yes or no? Which means during compaction, just like consolidation, I told you during consolidation, some of the properties increases, some of the properties decreases. So let's see what are the properties that increase and decrease. If you observe, see here, the water content is going to be less. Yes or no? Here the water content is going to be less. And here the water content is going to be more. So now let's say this is going to be dry side. And this is going to be wet side of optimum. And now I'm going to call this one as a dry side. Wet side of optimum and dry side of optimum. So I'm going to take, if this is the optimum moisture content, whatever the water content more than OMC will be wet side of optimum. Whatever the water content less than OMC will be dry side of the optimum. Because on the dry side, the variation is rising. On the wet side, the variation is going to be falling. So now let's see. First, shear strength. shear strength. As you know, the shear strength means as gamma d increases due to densification. What is the meaning of densification? The particles will come close together. Shear strength increases and becomes maximum at OMC and comma beyond OMC due to beyond OMC again shear strength decreases. Shear strength is going to be decreases. Sir, why sir? Because beyond OMC, you see, water will be taking place in the space of solids or not? See, as gamma D increases, shear strength increases. Gamma D decreases, shear strength is going to be decreases. On wet side of optimum, or simply I can write this one as shear strength increases on dry side of optimum, and beyond OMC shear strength decreases on wet side of the optimum. Think of that's it. I'm writing all these points now. Second one, permeability. You know that it completely depends on size of voids. Yes, size of voids. So now during compaction, as particles moves closer, what happens as particles moves closer? The void space will be decreases or not? Then permeability will decrease. Permeability decreases on dry side, but now permeability will be minimum yet or above optimum moisture content. See, you know that as the compaction is going to be happen, as the particles comes close together, then the permeability is going to be decreases and it can be minimum at the OMC or just above the OMC and then slightly increases and slightly increases, but the permeability will be always less on wet side compared to dry side. See, during compaction as particles move closer, permeability will decrease on dry side and it will be minimum at or just above OMC and then slightly increase but mind it, always the permeability on the wet side is less than the dry side compared to dry side. Even though it increases, its value is less than the, so which means permeability on wet side is less than compared to permeability on the dry side. Sir, what is dry side? Okay, fine. Now, those who wants to take a screenshot, you please take it. Those who wants a screenshot, you please, you can take the screenshot. Because some of the people are asking, so previous slides, okay, fine. You have this slide also. Those who wants to take screenshot, you can take the screenshots. My dear anonymous attendee, sir, how K is more on dry side? Because on dry side there will be entrapped air, right? So K will be, hey Baba, this is not normal soil, this is a compacted soil, okay? See, we know that on the dry side, K value will be less and it will become minimum at optimum and then slightly increase on the wet side. But what I am saying you is, once the permeability is going to be decreases on the wet side, it slightly increase, but compared to the dry side, always on wet sides, the permeability is less. Compared, see, this is just, I made a comparison. Don't think that, you see, this is comparison, you please observe. So, but the permeability always, let's say, wet side compared to the dry side. I am telling you, compared to the dry side, on the wet side, the permeability is going to be less. Sir, why this chapter is boring? Consultation was very interesting. What to do, man? Because consultation has a lot of formulas and concepts and everything. But this compaction, just we have to compact it. So that's the reason why we are going to finish this one with this today. Today it will be finished. Yes, does bulking give an importance practically? Yes, you have to give bulking because while you are going to compact the loose sands, you have to be careful. Sir, will zero void curve be same for standard and modified test? Zero void is for the soil, not for the standard or modified. So don't worry about that. Sir, what you thought in this subject, is it enough for state service exams also? Yes, it is completely enough for the state service examination. You please go through the previous state service examination questions. You can solve all questions. Bulking means increase in volume. How many times I say the same thing? Okay, fine. So now let's come to the third one. Swelling potential. Now, you please tell me, see, why I am discussing all these things is in practically, we are going to compact the soil mass for various significances. I told you the necessity of the compaction is to improve strength, to reduce the swelling, to reduce settlements, to improve the stability and all those things. Yes or no? So now, based upon those, we have to compact. If my point is to reduce settlement, I have to compact with 1%. If my point is to reduce the permeability and to reduce the swelling, I have to compact on one side. So that's why I pick one side as a dry side, other side as a wet side. Now, you see swelling potential. Soil in dry side of optimum has more water deficiency, yes or no? Soil which is having a soil in the dry side of the optimum has more water deficiency and can imbibe. Imbibe means it can absorb water, can imbibe water immediately, results in more swelling compared to wet side of optimum. Compared to wet side of optimum. See, I can say you one simple example. For example, you are thirsty. You are thirsty means so your lack of water, your body is lack of water. You have water deficiency. Then what you do? You have a capacity to drink more water, right? Yes or no? Which means your ability to take the water is more when you have water deficiency. But let's say you have already drank this bottle full of water. You have already drank this bottle full of water. Now, if I give you one more bottle, already you have drank full of water. Is there any water deficiency? No. So if I give you one full bottle, again, not full bottle, I'm saying the water bottle. So if I give you one more water bottle, then do you think, can you drink more? No, your ability to drink will be less. The same way, the swelling potential also. So, if you compact on the dry side of the optimum, you see, if I take the soil on the dry side of the optimum, it has more water deficiency and can imbibe water immediately, which means can take the water immediately. Results in more swelling, means more swelling potential. Potential means ability compared to wet side of the optimum, because on the wet side already soil has like sufficient amount of water, right? You please tell me, think and say. So in which case the soil has a more on. So whatever the done, I have done whatever things I have written is gone. I hope you people have take the screenshot. So I'm very thankful to one of the student because he was the one, he or she is the one who said, "Sir, please allow us to take screenshot so that we can send you to." So now I allowed you to take some screenshots. Please send it me back, whatever the screenshots you have taken. So for this one means whatever the topic I mentioned just now. Let's see how those have been. No. Okay, fine. Before the break, it was there, but after the break, whatever that happens today, a lot of disturbances were happening, but still we are going. We need to go. No other alternative for us. Let me check how many are there for us. So you please send me from the factors affected by the compaction means whatever the water content and everything, you please send those files to me. My mail ID, I told you my mail ID. My mail ID is pawan.acefaculty@gmail.com. So this means this is my mail ID, not was. Okay. Your smile is bliss to us. Read these comments also. You're just reading the hated comments. No, I am reading these comments also. So thank you. Thank you for those. Okay, fine. So now I was saying you about the swelling potential. So again, so let me take the same figure. So in the same figure, again, I'm not going to explain total, but so you know that on the line of optimum, so OMC on the dry side and is going to be wet side. So now I have been explained you three topics, which is going to be strength, permeability, and swelling. So I gave you an example. Swelling is just like you think you are thirsty. You want to drink more water. You are lack of water. On the dry side and compared to the wet side, swelling is going to be less. So now coming to the shrinkage. See, in the case of the shrinkage on dry side, as water is less, shrinkage will be less compared to wet side. So on the dry side, as water is less, shrinkage will be less compared to the wet side. And then the last one is going to be soil structure. So in the case of clays, so in the case of clays, you see on dry side, you observe here, on the dry side, as the water content is less, the soil will be very stiff. Yes or no? When the soil is very stiff, then the net attraction forces are more. In case of clays on dry side, in clays, I'll write the point over here as in clays, during compaction on wet side, on the dry side, soil is very stiff and net attraction forces are attraction force is more than repulsive force. Because you know that in the case of the dry side, what happens is particles are going to be closely packed or not. So there is a net attraction. See, attraction forces are more than the repulsive forces. So net force is attraction and structure is flocculated. So you know that, have you remembered the flocculated structure and dispersive structure? Yes. If you would have remembered the flocculated structure and dispersive structure, so now if you have remembered, please, I am getting a call. Okay. So now, see, I am writing the points clearly because as there is a small lag in the audio, that's the reason why I am writing each and every point clearly over here. In case, during compaction on dry side, soil is very stiff and attraction force is more than the repulsive force. So net force is attraction. Net force is attraction and structure is going to be flocculated. So with this, I can write dry side net attraction force. So net attraction force means what is the structure? You know that structure is going to be flocculated structure. And wet side, if you go for the wet side, now you please tell me, in the case of the wet side, net repulsive forces. Net repulsive forces. In other words, can I say in other words, you please have a look. You know that on the dry side, strength is more. Yes or no? When the strength is more, I told you in chapter number 3, clays, there is a swelling, there is a flocculated structure, there is a dispersive structure. In the case of flocculated structure, strength is more. In the case of dispersive structure, strength is less. Now with this, if you remember, I told you on the dry side, strength is more. Why? Because net attraction forces. On the wet side, strength is less. Why? Because net repulsion forces. Then what is the structure? Dispersed structure. So you can see the structure as a dispersed structure. So now I can write here itself. If it is in the case of clay, here flocculated structure, and here it is going to be dispersed structure. So these are some of the factors that got affected by the compaction. I told you the structures, and I told you the swelling, I told you shrinkage, and I told you the permeability. Now let me write everything in a small table so that you can able to understand and you can remember. I have given you the explanations. Now I'll be writing in a table. So property, dry off optimum and wet off optimum. Dry off optimum and wet off optimum. So whatever the properties I have been discussed, shear strength, permeability, swelling potential, shrinkage, soil structure. Look, in the case of the shear strength, in dry side of optimum, more shear strength. Yes or no? So in dry side, net attraction force is there. So the strength is going to be more. The structure is going to be flocculated. And on the wet side, the strength is going to be less. The structure is going to be dispersed. And this is exclusively for the clay soils. And now, in the case of clays and permeability, means whatever the soils, in permeability, this value is going to be C. This value is going to be on the dry side, it is less. And on the wet side, this is very less compared to wet side, compared to dry side, See, in the case of the permeability, on dry side, as you compact the dry of optimum, the permeability is going to be less up to optimum, and very less it is going to be compared to the dry state. And coming to the swelling potential, I told you on the dry side, as there is a water deficiency, soil has more ability to undergo swell. So the swelling is going to be more on the dry side and less on the wet side. Okay. Now coming to the shrinkage. Shrinkage is less on the dry side and more on the wet side. So these are the things that we have been learned so far by knowing the factors affected by the compaction. So you please go through the points. I have given you the points also. Mr. Amit, whatever the swelling we have seen, consistency chart is different and this is different, Nana. Added any compaction. Have we done any compaction? No, but this is a compaction. See, I am telling you the effect of compaction, not on the normal soil. Effect by compaction. See, this is due to compaction, not the normal cases. Flocculated means, you please go through the chart, chapter number 3, there you will get the flocculated means. What is the meaning of flocculated? Due to wetness, there will be some cohesion, na? Then how come there will be, Are Baba, I am not saying the repulsive force, I am saying the net repulsive force. What is the meaning of net repulsive? You see, in the case of the clays, the soil is very stiff and attraction force is more than the repulsive force on what side? On dry side. So net force is attraction, the structure is going to be flocculated. Similarly, on the wet side, what happens is repulsive forces are going to be more than the attraction forces. So there the structure is going to be dispersed. So now, please explain permeability on the wet side, because as water content increase, permeability should increase. Who said that permeability increase? I told you now. You see, you please go through the point once again. So I told you, beyond OMC, the permeability increases slightly, but that value is always less than the compared to dry side. You please go through the previous point. If you have taken a screenshot, I explained there clearly. Now, everybody, have a look at your things and how shrinkage will be more on dry side. See, don't apply your perspectives. I am telling you during compaction. during compaction. So on dry side, as water content is going to be less during compaction, I have to write every point, right? So, okay, fine. During compaction, shrinkage will be less compared to the wet side, because during compaction water is less, right? So shrinkage is going to be less. What is meant by shrinkage? Reduction in the volume. Sir, why there is a slight increase in the permeability, sir? Because on the wet side of optimum, suddenly the water will take more space than the solids. So that will cause a slight increase in the permeability. But that value is less compared to the dry side. Told you to allow us to take screenshot. I anticipated the situation. I'm doing crash course under God Tank Monitor. Okay, my dear. So you're doing very good crash course. So as you're doing some crash course, please tell us so what you're learning from the God, and when the coronavirus is going to be ended. So Tank Monitor, yes, and tanking Innova itself. Yes, the start will be completed. It's almost everything completed. Sir, which chapter is this? Which chapter is this? Okay, fine. So that's all with this. See why I am focused about these conditions is now this table is very important. Why? Because there comes the end point. Look, everybody. So far I have explained you. Listen, everybody. So far I have explained you what is a compaction test, standard Proctor test and modified Proctor test. And the second one is what are the results and how we plotted the graph. And then I explained you what are the factors affecting the compaction, affected by the compaction. And one more thing, see, the management has asked me to do one thing. See, by 4 o'clock today, by 4 o'clock, let's see, by 4 p.m., you will get a mail from Ace team, what is this? They said one thing, I forgot. Yeah, okay, fine. A feedback form will be sent to you. As a link. So today by 4 p.m. means by not by 4 p.m. Today at 4 p.m. At 4 p.m. you will get a mail from AS team. A feedback form will send to you as a link to give a feedback on geotech subject and faculty, means about me. And I hope you know my name, Pawan Kumar. So my name is Pawan Kumar. So everybody PM, you please open your mail and you can get a link from the AS team. A feedback form will send to you as a link to give feedback on this chapter. Who are we to give you feedback, sir? You are amazing teacher. Thank you, my dear. That's very good. But see, like as it is between you and me, means between you as a student, me as a faculty, but the ACE team also should know how the class are going on, and they at the end of the day, you are the one who is going to be judged. So that's okay. Fine, you don't need to give now, but you please open that link and you give that. Okay, that's very good. Please. Sir, నేను అంత కష్టపడి మెసేజ్ పెట్టి చదవలేండి సార్. I'm sorry because I am not able to see all those feedbacks. Okay, fine. But okay, fine. Now we have to look over the completion of this. Means completion of this chapter. It's already 12:50, so within 10 minutes we are going to conclude this chapter. It may take 15 minutes also. So now let's see, because of this in between problems. Now, why we actually required these points over here. Look, I told you earlier, my necessity is about to improve the strength. So if I want to improve the strength now, if I want to improve the strength, on which side I have to compact? I am going to compact on dry side of the optimum, because you know that compared to wet side of the optimum, we are going to, if you compact on dry side of the optimum, the strength is going to be more. And now, in the case of earth dams, you have seen, I hope you remember the earth dam, and you know there is a phreatic line passing through the earth dam. Yes or no? So in the case of the earth dams, the center portion of the dam will be compacted to reduce the swelling potential and to reduce the permeability. So if you want to reduce the uneven volume change, which is meanwhile swelling, and if you want to reduce the permeability, we used to compact on wet of the optimum. So as a design consideration, now I am going to say as so for engineering practices, for engineering practices, you need to improve strength of the soil it should be compacted on okay, to improve the strength of the soil it should be compacted on dry side of optimum. So it should be compacted on the dry side of optimum. Again, what's this soil proof problem? Please, don't now. because it's already okay, fine. So to improve the strength of the soil, it should be compact on dry side of the optimum. You know that why? Because if you compact on dry side of the optimum, the strength is going to be more on the dry side. So example, where we are going to construct means where we are going to do this one is in the case of embankment and outer portion of earth dam. In the case of the embankment and outer portion of earth dam and pavement construction, there we are going to use to improve the strength of the soil mass. It should be compact on dry side of optimum. And second point is to reduce swelling potential and permeability, soil should be compacted on wet side of optimum. Soil should be compacted on wet side of optimum. Sir, why we have to compact on wet side of the optimum, sir? See, in the case of example now, core of earth dam. Core of earth dam. So in case of core of earth dam, in the case of core of earth dam, black cotton soil would be there. In core of earth dam, black cotton soil would be there. Oil is present. To reduce seepage and swelling, it should compact on wet side. It should compact on wet side. Because in the case of the earth dam, if you see, still sir, already on dry side strength is more, so we can compact on wet side so that we can get more strength. Arey bhai, ye kya hai bhai? This is a doubt you are asking, please. Ray. I have written right. On the wet side of the optimum, the strength is going to be less. If you compact on wet side, the strength is less. So we compact on the dry side. Yes. So now, if I draw an embankment or an earth dam, please have a look. You observe, this is an earth dam. In the case of earth dam, this is a shell portion and this is core. Core means center of the earth dam. In the case of a shell portion, we are going to mix a coarse grain plus fine grain soil. And in core portion, we are going to take a black cotton soil. Black cotton soil. You know the black cotton soil has a very less swelling, sorry, is a high swelling in nature. So in the case of the black cotton soil, on the core, you need to compact the soil mass to reduce the swelling and to reduce the seepage. How to reduce the seepage? How you are going to reduce the seepage? If you reduce the permeability, then you can reduce the seepage. So to prevent the seepage or to reduce the seepage and swelling, it should compact on wet side. Because you know that when you compact on the wet side of the optimum, the swelling potential is going to be less. So the soil will undergo less swelling. Now, these are the for engineering practices we are going to do to improve the strength. We compact on the wet side of you compact on the dry side of the optimum, and to reduce the swelling potential, we compact on the wet side of the optimum. Now, the last topic in this chapter. Yes, sir, but black cotton soil has high swelling and shrinkage. Then is it dangerous to use on the core of the dam? See, in the core of the dam, that's the reason why we are compacting on wet side, right? See, this core is going to be black cotton soil mass. Already black cotton soil has less permeability. Yes or no? So if you compact on wet side, its permeability is going to be much lesser and swelling is going to be very, very less. So now the last topic here is compaction equipments. With this we can conclude the chapter, and one formula is there. Compaction equipment. Because of this lagging problem only I am going too slow, otherwise I would have completed the chapter so far. Compaction equipments. So now in reality, what are the equipments that we are going to use? In reality, what are the equipments that we are going to use? So please, if you have taken a screenshot of the, if you have taken of the please send it to me also. Only for the practical. So now I'm discussing about compaction equipments. Compaction equipment. So now type of compactor and type of soil for which it is going to be suitable and nature of to use this one. Look now, you see, so why we are going to use this one, sir? See, I explained you the factors affected by the compaction, and I told you in order to improve the strength, we compact on dry side of optimum. Please keep that in your mind. That is very, very important. If you want to improve the strength, you compact on dry side. If you want to reduce the swelling potential and reduce the permeability much more, then compact on the wet side. I gave you example in embankments, we usually compact on dry side. In earth dam, for the shell portion, means outer portion is for the strength and inner portion is to reduce the swelling. Now, my question is, are you going to compact, means in the reality, now in field, are you going to compact exactly, by using the same rammers we use in the laboratory? No, we have different compactors in the laboratory, means in the field. So now what are those? One by one. First one, rammers. So these rammer means a small compactors. This is suitable for all soils. Whatever the rammer I said you in the laboratory, right? That is suitable for all soils, but it can be used for confined, which means back of retaining wall, sheet piles. C, or you can say back of retaining walls and back of and basement floors. See, on the back of a retaining wall means to retain the soil. On the back of a retaining wall, whatever the soil we are going to impart, and say if you see the highways or if you see the flyover, means I hope you have observed the flyovers also. So if you see the flyover bridge, there you can see on the sides there are some walls are not, and this is the road, this is a side wall. To compact such soils, confined areas, we are going to use rammers. And second one, smooth wheel rollers. Smooth wheel rollers. These smooth wheel rollers we used to use only for the and you observe, I hope you have seen this. See, whatever I said, you have seen all these things in reality. When you are going to see the road construction, at the end of the road construction, have you ever observed a big roller is going to be passing over the roads or not? See, it has some steel drum and that is going to be smooth, which means a smooth. Wheels are going to be big drums are going to be there. The wheels are going to be big drums. So such a type of rollers are known as a smooth wheel rollers, and this is going to be used during construction of roads. We are going to use this a smooth wheel roller. And then the third one, pneumatic tired rollers. Pneumatic means a pressure. This is for all soils. This can be useful for all soils. So generally we use this one to compact shell or outer portion of earth dam. Earth dam means E-dam means earth dam. And now sheep foot rollers. Sheep foot rollers. This is for the clayey soils only. This is for the clayey soils only. So sheep foot rollers are for the clayey soils. Now in this case, you observe, I told you in the previous, I told you to compact core of earth dam. The core of the earth dam, black cotton soil would be there. BC means here black cotton soil would be there. So in the case of the core of the earth dam, what is the type of soil we are going to see? The black cotton soil. And the type of roller used to compact for clayey soils especially is the sheep foot roller. And for all the soils, you can go for the pneumatic roller. For cohesionless soils, we can go for the smooth wheel rollers. And the last one is vibratory rollers. And this vibratory rollers is used for sandy soils. And the nature of the project we are going to see here is to compact embankments. To compact embankments. To compact embankments, we are going to use the vibratory roller. So these are the different type of rollers we are going to use in the compaction. Grid rollers, we don't need to go for the such. See, there are apart from this, there are a lot of rollers, frog rollers, grid rollers. No, we don't need to go for all those things. These are the main equipment, compaction equipment mainly. And I have given you all the points. I have given you all the points regarding to the compaction. So where to compact, whether it is a dry side or wet side, depends upon the strength or swelling. And how to compact, these are the variables. And at the end, relative compaction. Relative compaction. So relative compaction means it's a ratio of dry density attained in field to maximum density attained in lab. Maximum density attained in the lab. So this relative compaction RC is equals to maximum dry density attained in the field to maximum dry density attained in the lab into 100. So this is going to be the relative compaction. See, in this chapter, I told you, first of all, we have compacted the soil in the laboratory by using standard Proctor test or modified Proctor test. Then we got some results. What are those results? What happens on dry side and what happens on the wet side? Based upon those results, I can fix whether I can go for the dry side of optimum. If you want to improve the strength, where you need to compact, dry side. Okay, so I can compact the dry side of the optimum, and I can compact by using these compactors. Now my question is, do you think whatever the dry density you attained in the laboratory and whatever the dry density you are going to attain at the end of the compaction in the field, both are same? No, they are not going to be same. And how much it is, we are going to find out by using this relative compaction. So this is the formula. We are going to see this one as a relative compaction. Now, continuously it is going off, but fortunately it is there. So now this RC can be less than 1 or it can be 100% also. It depends upon the factors you are going to take in the field. So now, can I write this one as in terms of UC? You know that gamma D is nothing but G gamma W by 1 plus C R naught. Gamma D is nothing but G gamma W by 1 plus C. So can I write from this gamma D is inversely proportional to 1 plus T. So can I write this relative compaction is equals to 1 by 1 plus E by 1 by 1 plus E minimum. 1 by 1 plus E by, see, whenever this is going to be gamma D max, have you remembered the relative density? So now I can write, if it is going to be gamma D max, then E becomes E minimum. So I can write this one as a relative compaction can also written as 1 plus E minimum by 1 plus E. So I can give you the minimum wide ratio, then you can get this one. And now, sir, have you remembered the relative density ID? ID means E max minus E minimum by E max minus E by E max minus E minimum into 100. So don't ask me, sir, why you have written E as E minimum over here. Please, I told you, when gamma D is more, E is going to be minimum. There is a small relation between the relative compaction and ID. That relative compaction is equals to 80% plus 0.2 times of ID in terms of a percentage. In terms of the percentage, in percentages. See, this is a relative compaction, and what about this relative density ID? I hope you remember this relative density ID. So now I can give you that relative compaction as, see, it can be less than 1% or it can be more than 1%. So it can be less than 1 or it can be 100% also, but it cannot be more than 100%. So this relative compaction is equals to 80% plus 0.2 times of ID. 0.2 times of ID. So now, if you observe, listen carefully. If the soil is going to be fully dense state, what is ID value? If the soil is a highly dense state, I hope you remember the ID ranges 0 to 35, 35 to 65, 65 to 85, 85 to 100. If ID is going to be more than, if ID is going to be 100, then it is going to be highly dense. Substitute 100. When ID is going to be 100, when ID is going to be 100, what is the value? When ID is going to be 100, the value is going to be 0.2 in 100, 20, 80 plus 20, then relative compaction is going to be 100%. And if the soil is very loosest state, then ID is going to be how much? 0. When ID is 0, what is relative compaction? 80%. So mind it, the relative compaction must be more than 80%. Must be more than 80%. So, I mean, you can see this relation. From this relation, I am saying the points. So that's all with this chapter. And you please try to solve. There is only one question. I am giving you that homework. Yes, there is only one question. You see, these questions are there, two questions are there. I am leaving you these questions for you. See, this is the compaction chapter, and in the compaction chapter, if you observe, there are two questions. Question number 1 and question number 2. So just now I discussed that the minimum void ratio, maximum void ratio topics are there. So those does not take a day, these does not take much time. You please go through these questions. Then we'll see the remaining things tomorrow's class. Tomorrow I'm going to start a new chapter. The new chapter is going to be shear strength. That is very, 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 very important chapter. Okay. So that's all with this today's topic. Please send me the slide before this one. I have explained you that slide, right? So I want you to send the factors from the point factors affecting the compaction onwards. I want you to please send me that, so I can attach that into the PDF. That's all with this. Those who wants to leave, they can leave. So now I'm going to enable the, I'll be taking the doubt clearing session. So I have already saved these details. So now you please open the, means I have saved these things. Now I am enabling the, those who wants to leave, they can leave. I am enabling the raise hand option. So I'll be taking a doubt clearing session for the next 20-25 minutes, because already it's 1:20. Today it's so hectic. Sorry for today's all these things. I'm really sorry for what has happened because of these internet connection issues. Even, I mean, once we miss the flow, also it will be difficult. So now that's all with this chapter. Now, Mr. Anonymous attendee, now I'm going to explain that CRPQ fifth question. So please wait. So what is the usage of relative compaction? What does it mean? What obtained in lab is that executed on field? Is what? See, in the case of the laboratory, we obtain by confined conditions and we compact very small amount, yes, and we get some maximum dry density. But if you go for the field, in the case of field, due to man errors, means human errors would be there or not. So while you are doing compaction, you may not attain the same density that you attained in the lab. So in order to check how much compaction you got, we are going to use the relative compaction technique. See, all the things are important for the glade, means yes, they are. Sir, in the subgrade below pavement as a swelling plays a major role. Should it be out for the wet of optimum? Yes, you can see. In order to improve the strength, also we can go for that. And below the optimum means the swelling is going to play a major role. So in the case of the pavements, we can go for wet of optimum also. Else I will write and send it to you. No. So let's see the people who has raised their hand. Mr. Amit, you can speak now.
Hello.
Mr. You can speak now.
Hello.
Yeah, Amit, tell me.
Hello.
Yeah, I am. Yeah, tell me.
Sir, previous gate question 7, 2003, chapter 11.
Please speak out loud.
Sir, previous gate 2003, question 7, chapter 11.
Chapter number 11.
Two mark question.
Two more question. 2003.
Yes, sir.
Yes. Which question number 5? Yes.
7. Sir, in this question they have given pressure octane.
Yes, yes. Figure shows the geometry of a strip footing. Actually, as it is a strip footing, while you are calculating, you have to use the formula. Okay. So
Okay.
here, yeah, I got your doubt. Yeah, first you say your doubt and I'll explain that also. Tell me.
Sir, in this question they have given pressure acting on the footing is 40 kilopascal.
Yes.
I calculated effective stress at 3 meter by that formula, strip footings formula.
Effective stress. Huh?
Yes.
Yeah. Okay,
but,
fine. So this is the way we are going to find out.
Yes.
Yeah. I hope that you have find out this delta sigma dash by using q by pi into 2 sine 2 theta. Yes.
Yes.
This is for strip footing.
Yes, sir.
Okay, but you see, if you do this one, the answer is going to be very, actually you have to solve in this way only. So what is the q over here? 40 by pi into 2 theta sine 2 theta, where theta is equals to tan inverse of b by 2 by z. Yes?
Yes, sir.
So they have value, and tan inverse of 0.6 by, what is the z value? 3. If you solve this one, what is the value you are getting? Please tell me.
I don't have it right now, sir, but total value is 9.90 effective stress.
Total value or sigma naught dash?
Sigma naught dash, 9.90 kilopascal.
Sigma naught dash means, you see, gamma of bulk into 1 plus gamma dash into 3. Because beneath the strip, you have to take the center of the clay layer. So 18 into 1 plus gamma dash. So 20. Did I mention gamma W as 10?
No.
Yeah, you don't need to worry about that. You can take it as 10 because there is a multiple choice, right? Yes. Into 3. So 18 plus 10 into 3, which is going to be 30, which is going to be 48 kilopascal. This is sigma naught dash. Okay.
And
yes, I know what your doubt is. Actually, in the given question, if you solve this value, I'll be telling you if you solve this value. So the theta, I'll be telling you the tan inverse of 0.6 by 3, which 11.31 degrees, and in terms of radians, it is going to be 0.197. So if you solve this one, then the delta sigma dash is equals to 40 by pi into 2 into 0.197 plus sine 2 into 11.31 degrees. I hope you have solved the same way, yes?
Yes, sir.
2 into 11.31 into 40 by value. So you got this value as 9.92. Now, once you know this, what is the settlement over here? SF is equals to CC by 1 plus C naught into H to log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. So after solving these values, you are going to end up with, I'll be telling you the answer as 48 into H as 6 meters into CC 0.08 by 1.4. See, you would be getting the value as 0.0279. Yes?
Yes, sir.
27.9 mm.
Yes,
This
sir.
is the answer you are getting. But have you seen any answer over here?
No, sir.
Have you seen any of the answer over here? No. So that is the reason why what they have given is assuming because why they are assuming strip load as surcharge is why they take surcharge is the strip is going to be acting over a large length or not?
Yes, sir.
Yes. So if you assume the strip load as a large length because acting over large area, now you have to take the delta sigma dash directly itself as a 40. You have to take the directly delta sigma dash itself as a 40. So if you solve this, then what is SF value you are going to get? Please tell me.
Then it is 89.0, sir. C.
48 plus, yeah, 89.0. So then 89.0, which is going to be nearest option. See, in this question, actually, both ways are correct. Both ways are correct. You can ask me, sir, I have done this one, is it correct or not? Actually, this is the correct, but there is a one condition for the strip. What is the condition? If I calculate exactly below the center, only this equation is going to be possible. Yes or no?
Yes, sir.
But did they ask, sir, what is the settlement below the center of the footing? No.
No.
And more than that, they give the strip as it is going to be acting over larger surface area, we are going to assume the strip load as a surcharge. That is the reason why you got the ultimate settlement as 18 mm. For the given options, you have to take this one only.
Okay.
So that's where the answer B comes. Okay.
Okay. Thank you, sir.
Yeah. Next, Mr. Aditya, please speak out.
Hello,
Yeah, Mr. Aditya, speak out.
sir. I have doubt in GATE previous 11th chapter first question, sir.
2 marks or 1 mark?
1 mark, sir.
Yeah. Yes. Terzaghi one dimensional. So you have, I think you have sent me the mail also, right?
No, sir. I have not sent any mail.
Someone has sent me mail also.
Regarding this only, sir. Regarding the same question.
Regarding the same question.
11th
Okay,
chapter.
so this one, yeah. Terzaghi one dimensional theory assumes E versus P relationship is going to be linear. See, why assumption is going to be this one. This is Terzaghi's theory.
Yes, sir.
Normally, E versus log sigma
Log
P
P
is going to
is
be linear.
linear.
No?
Yes, yes, sir.
Yes. So why they have taken this one as linear is, if I can take this one as a linear, then the slope is going to be constant.
Yes,
So
sir.
generally, if they ask the relation between E versus log P, you can take it as linear. And
Yes, sir.
Terzaghi, he assumed permeability is going to be constant.
Yes,
What is
sir.
that?
Permeability is constant.
Permeability is going to be constant. As the
Yes, sir.
permeability is going to be constant, the reduction in the void ratio is also going to be constant.
Yes, sir.
According
Okay,
to
sir.
him, as it is going to be constant, the slope is going to be linear.
Yes, sir.
So that's why he assumed the E versus a P relationship is linear. Normally, if they ask, log P is going to be linear, but according to Terzaghi, relationship is understood?
Okay. Yes, sir. Yes, sir.
No.
Thank you, sir. That's it.
Mr. SSMB, Mr. SSMB, please speak out.
Hello, sir.
Yeah, Mr. SSMB, speak out.
Yeah, my doubt is regarding yesterday's problem, sir. Average loading period one. There 3 years are given, no, sir. 57, 58, 59. So we took
Yeah,
the
not
58 as the average loading period.
let me tell you, not 57, 58, 59. They have given from 57 to 59. Okay.
Yeah, yes, sir. Yes, sir. What if they give
The average is
58, 50?
I understood your doubt. You have already messaged me, right?
Yeah, yes, sir.
Yeah. Sir, what if it is 59, 57 to 60? Then what is average? That is the question you are asking, right?
Yes, sir.
Yeah. Then what is average? 1957 plus 1960 by 2.
Yes, sir.
1957 plus 1960 by 2, which means 1958.5.
Okay. I didn't get it, sir. 57, 58, 59, 60. 4 years, no, sir. For 4 years, the how can it means how can it be 0.5?
Started from 57. It started from 57. It went for the 60. The average is going to be taken as 57 plus 60 by 2,
Okay,
which is
okay.
going to be, what is this value? 57 plus 60 by 2, 58.5. 57, 58, 59. Then the average is exactly at 58.5, right?
Yes, sir. Yes, sir. Hello.
That's it, the average.
Yeah, okay, sir. Thank you, sir.
Understood now?
Yeah, yes, sir. Got
Yeah,
it.
yeah. Yes. My dear Anonymous, you are asking me to, sir, can you please solve the classroom practice questions? So I'm going to solve now. You please have a look if you are being there. Now, see, this is a GATE 98 question only I have been explained. Now, those who wants to go for the question number 5 also, you can please look over this question number 5. See, the time required. The time for a clay layer to achieve 90% consolidation is 15 years. And the time required to achieve same 90% consolidation. So same degree of consolidation, my dear Anonymous, TV constant. Okay. The time required to achieve same degree of consolidation if the clay layer were twice as thick, which means 2 times of thickness, and 3 times more permeable, and 4 times more compressible. You know that TV is equals to CV into T by D square. CV is constant. T directly proportional to CV, D square by CV. And you know that CV is equals to K by MV into gamma W. So from this, can I write T directly proportional to D square and inversely proportional to CV, right? Which means by K into MV by K. So now this is the final relation. So if you observe, T directly proportional to D square by CV, where CV is going to be K by MV into gamma W, you substitute over here. Then T2 by T1 is equals to D2 by D1 whole square into K1 by K2 into MV2 by MV1. So now from this T2 by what is T1? 15 years is equals to the time required to achieve 90% consolidation if the clay layer was twice as thick. Twice as thick means D2 is going to be 2D. Twice as thick by D whole square into 3 times more permeable. If I take K1 as K, 3 times more permeable means K2 is going to be 3K into 4 times more compressible. If I take MV1 as MV, 4 times more compressible. So now MV will get cancelled, KK will get cancelled, DD will get cancelled. So from this I can write T2 by 15 is equals to 2 square, 4 by 3 into 4. Yes, I hope this is the value. Yes. So now you take this value to over here. You take this value over here, 3 5s, then 5 into 4 into 4, 5 4 20, 20 into 4, 80 years. The answer is going to be 80 years. It's just simply, this is the thing that you need to understand. If you apply this one, then you can get it done. So now I hope your doubt has been cleared, Mr. Anonymous. So if it has clear, please comment in my section. So is it cleared or not? So that I can go for the next one. Meanwhile, some of the people who are waiting. Mr. Sachin, now you can speak out. Mr. Sachin, please speak out. Mr. Sachin, I hope you are not able to speak. So please speak out. Otherwise, I'll go for the next person. Miss Rutuja Khole, please speak out.
Hello, sir.
Yes, Rutuja, tell me.
Sir, will you please explain GATE 10 chapter 2 marks for first question?
Chapter
10 chapter 2 marks first question, sir.
You see this question now?
Sir, actually the arrow seems to be incorrect. Direction of arrows.
Okay. Let me see that one. Yes. So now you see the flexible footing on cozy soil. See, the meaning of flexible is settlement is going to be there. Yes or no?
Yes.
Yeah. Okay. I understood your question. So they have given the incorrect
Arrows. Direction of arrow.
Yes. No, I don't think it's incorrection of arrows. The problem is over here. You please observe. See, everyone now you are there, right? You
Yes.
Please observe this one. Due to this, now you see the footing has settled the same. The footing has settled the same. See, the settlement is going to be same. The downward, they did not represent the downward movement. That's the reason why you might got confused. So let me. Yeah. If you see this one, see here, the settlement is going to be uniform everywhere. This is meaning of settlement, okay?
Okay, sir.
The settlement is uniform. When the settlement is going to be uniform, then what is the type of footing it is? Rigid footing or
Rigid
flexible
footing.
footing?
Yes. Yes, sir. Rigid footing.
Yes, very good. Yeah, and moreover, that this is going to be contact pressure distribution or not?
Yes, sir.
Yes or no? And at the center it is going to be more, and at the sides it is going to be zero. So definitely this is a
For
rigid
sand. Footing.
on sand. So where A is going to be rigid motionless soil. So this is going to be 3. Now you come over here. Here also you see the dotted line is there or not?
Yes,
This
sir.
dotted line is our settlement. The settlement is going to be. But here at the center the stress is more or less, and this is rigid on clays. Okay.
Okay, sir.
Okay, understood?
Yes, sir.
Similarly, you come over here. Now you see here does the settlement is going to be uniform. See, this is a curve. The footing shape is going to be like this. Here, this is the settlement is going to be uniform now. No.
No, sir.
Are you able to understand?
Yes, sir.
Yeah. When the settlement is not uniform, this is going to be flexible. And you see, they have given the base of the footing and below pressure everywhere. This value is going to be uniform or not? This contact pressure, see, if this is the base, and if I mention you, this is the pressure distribution, then you can say to me the contact pressure is non-uniform. But if you see the shape of the footing over here, the actual shape of the footing, due to this uneven settlement, this is the base of the footing, and this is the base of the pressure. So everywhere the pressure value is going to be same or not?
Yes, sir.
And
Contact
now,
pressure is
if you
same.
observe, in this, settlement is is more, the settlement is more on whom? Edges. Settlement center. So settlement more on the edges, which means more on the edges, more at the center. Settlement is less at the edges. So this is going to be flexible on clay. I hope you understood now. Understood?
Yes.
Arna?
Yes, sir.
Yes. See, they have given the contact pressure once the footing has been settled. Na? After the settlement, they have given the contact pressure. Okay.
Okay, sir.
This one, this representation and this representation both are same because there is no change in the pressure. You please look over the arrow marks. The magnitude of the arrow marks is going to be same everywhere. So now for this, what is this? So be rigid on clays, rigid on portions of soil. This is going to be 2, and this flexible sand on. So this is going to be 4, and this is going to be 1. The answer is going to be 3 to 4 1. You please check that. I hope you understood, Rituja. Okay.
Yes, yes, sir.
Yeah. So now I can go for the further. Any other doubt?
No, sir.
Yeah, thank you. Mr. Kaushik, sir, why is permeability less than that of dry side? Even the water starts to occupy and increase the net volume, and in that case, water increase the permeability of water. Water will not increase the permeability of the water. Permeability is based upon the soil mass. I told you on the wet side, permeability increases slightly, but compared to the dry side, it is less. You please go through the point once again. Now it already been 1:45. I will be taking 5 more minutes because I have to rush up. I'll be taking 2 more calls from you people. What is the value of compaction energy for standard Proctor test? You please go through the notes I have given already. Don't ask me the same things again and again. Mr. Pavan Kalyan, you can speak out now. Mr. Pavan Kalyan, you can speak out now.
Sir,
Yes.
can you open previous ESE chapter 11?
Yes, tell me.
In the 24th question, sir. Chapter 11, 24th question.
Twenty-fourth question.
Yes, sir.
Yes, this is the one. Yeah, tell me, Pavan.
Sir, in that I understood the first statement, sir. I didn't understand the second statement.
Suffers an ultimate settlement of S under increase of pressure of delta P. When a thin sand layer is present at its mid depth, the layer under otherwise acting connection will have no change in the ultimate settlement. Okay.
Yes, sir.
The path of travel of water for the clay layer is H under single drainage. When a thin sand layer is present at the mid height of the clay layer, the considerably reduces the time required for realize the ultimate E.
Sir.
The question I want to ask you is, see, ultimate settlement does not depend upon time. First one
Yes,
thing.
sir.
Okay.
Yes, sir.
But what happens over here is, if you provide a double drainage,
Yes, sir.
magnitude of the settlement does not change. For example, you see, I'm telling you this example, just you observe. For example, if you stop eating breakfast, means 3-day meal, you are missing 1 meal per day. Let's say you reduce 10 kgs you reduce 5 kgs within a month. You stop eating, let's assume, you stop eating 1 meal per day and you are going to reduce 10 kgs per month. Okay.
Okay, sir.
Now, if you stop eating 2 meals a day, are you
Okay.
going to have the same 5 kgs within 1 month or less than 1 month?
Less than 1 month.
The same thing happens over in the case of the soil also. If the
Okay.
soil is going to be single drainage, if the soil is going to be single drainage, let's say the ultimate settlement reaches by 10 years.
Okay.
But if the soil is going to be having double drainage, then the water will dissipate easily or not?
Yes, sir. Yes, sir.
Then the time required will be 1/4 of the time required for the single drainage or not?
Yes, sir.
Then it is going to be 2.5. But the magnitude of the ultimate settlement remain same. The
Okay.
time will be changes, but the magnitude of the settlement will be remaining same. Okay.
Okay, sir.
Yeah, I hope you understood.
The option would be
Yeah. A clay layer of thickness H with a single drainage suffers an ultimate settlement of S and an increase in pressure of delta P. When a thin sand layer is present at its mid there, the layer under otherwise will have no change in ultimate settlement. Yes.
is
The
true.
path of water for the clay layer is H under single drainage. When a thin sand layer is present at mid height, and that in upper half of the layer gets reduced to H by 4. This considerably reduces the time required to realize ultimate settlement. No, see, statement number 1 is true, assertion is true, and the reason is also going to be true, but assertion and reason are not, reason is not correct explanation of A. What is the answer they have given?
That one only, sir. Option B.
Yes. Why it is not true E here is the change in ultimate settlement is 0 because its thickness is not going to be changed. The total thickness is same or not?
Yes, sir.
As long as total thickness is same, so they would have given that reduces time, thickness has not reduced. So ultimate settlement remain constant. If they would have given that reason, then the answer would be A.
Okay.
They did not
Okay.
give
Okay.
that reason, so answer is B. Okay.
Okay. And then next
Yeah.
question, sir. 25. Question number 25, sir.
Yes. Consolidation predicts settlement due to primary consolidation. It cannot include settlement due to initial compression, nor due to secondary consolidation. That happens following assumptions. Soil, grains, and water are incompressible. Yes. Soil is fully saturated. Yes. Compression takes place in vertical direction only. Yes. Time lag in consolidation is entirely due to low permeability of the soil. Yes. Everything is correct. Okay. Time lag in consolidation is entirely due to low permeability of the soil. Yes, everything is correct. Soil grains and water incompressible. Okay. What is the answers they have given? 1, 2, 3.
Sir, this question, it was repeated in 65th question as well, sir. In that question, they have
60th.
given answer as 1, 2, 3, 4.
60th.
65. The same question is repeated.
Yes. The answer should be 1, 2, 3, 4 because in the given options itself there is a C. That's not. I think there is a small mistake in the question itself. That given options, but answers are 1, 2, 3, 4. All the options would be there. Okay.
Okay, sir. Okay, sir. And
Yeah.
then 38 question, sir.
Today, see, Pavan, it's already 1:52 because already one more session is there at 2 o'clock. I have to leave now.
Okay. Fine, sir.
So we'll be seeing tomorrow. Okay.
Okay, sir. Thank you, sir.
Yeah.
Thank you.
Okay, fine. Bye.
Bye.
So I'm leaving now. The people whom I have not allowed to speak out. So you please mail your doubts to my mail ID. I'll try to give you the solutions as soon as possible. Please make it sure. I'm leaving now.